Hello, everyone. I hope you are doing well. Uh, Welcome to our Sudoku stream. Oh, Lake. Oh, we've done a few puzzles by Lake. We have enjoyed the puzzles by Lake. There was a story with Lake, I think, but I don't remember what it was. It's possible that Lake is a pseudonym for a group of setters. Maybe not. If anyone knows, let me know. I have faint recollections of this. Oh, you can see they drew the thermos in using that. Anyway, we'll look at that in a second. Welcome to everyone. No, Lake is a person. Okay. Who am I thinking of then? I don't know. Okay. Welcome, Bertie. Glad you're enjoying the streams. Hope you enjoy many more of them. Welcome, Peter, David, Paul Fly, I see as well. Let's go ahead and get into this. I think last stream I set a puzzle that I have not published yet, but I will eventually. I'll eventually work on that. I've been distracted with canning things. I have canned about 40 jars of peppers for the winter, preparing for that which the Midwest becometh. All right, so let's look at the rules of Lake's puzzle. So we have normal Sudoku rules. Hey, Jay, by the way. Adjacent digits along a German whispers have a difference of at least 5. Digits on a purple Renbon line are consecutive. Oh, hey, LSF. How's Comic-Con? I went to Comic-Con in, I want to say 2006, but it might have been 2005. In grad school, the person who lived next to me was a Marvel artist. Here with 130,000 of your closest friends. Yeah. I mean, I have to have been old to have gotten into Comic-Con, right? Unbelievable Lego set. Oh, awesome. Did you get the Lego set? Or are we going to replace the quilt content with Lego content? Because I'd like that too. But I love how many quilters we have who, if you do quilting, please post your quilt work or Lego work over in the zetamath Discord. I'd love to see it. Scale model of the convention center containing the convention center. Amazing. 250,000 piece Lego set. That would probably take me more than a day to put together, I'm going to imagine. Let's see. The blue line reflects prime numbers on each side. So if row 2, column 6 is prime, then row 6, column 2 is also prime. Okay, so this is kind of like parity mirror, but it's compositedness mirror. Okay, so for clarity's sake, 1 is not prime. Yes. I think I feel like it shows good instincts that people really want 1 to be prime. Like, I think that if you wrote down a definition of prime, it most likely would include 1 if you're not very careful about it. And then it feels very artificial to say, except we're not counting 1. But there are deeper reasons why it is a good idea to not include 1. Am I too nice? Or sorry, not too nice. Am I too loud? I think I didn't remember to adjust this thing back down, but let me know if I'm too loud. Oh yes, Triss doing the thing. Yeah, I'm famously too nice, especially about puzzles that I am solving. I think Triss checks our zetamath email, but I don't know if Triss has checked our zetamath email. But I will ask Triss to check the zetamath email because I'm guessing we just have not noticed. All right, so we've got our primes, which exclude 1, 4, 6, and 8, and 9. And so we've got 2, 3, 5, 7, and 1, 4, 6, 8, 9 are sort of our 2 colors. Yes, that is my usual go-to explanation, David, is that your fundamental theorem of arithmetic gets annoying if you want to include 1 in your set of primes. Although it also gets annoying if you want to like really precisely say what it means if you want to include negative numbers. So then you have to decide, is negative 2 prime? John Conway, the guy who made Conway's Game of Life, among many, many other things, famously argued that one should think of -1 as a prime. And so I think that is a sensible thing to do as well, because you can write down a version of the fundamental theorem. I think 0 to 0 really depends on whether you're an analyst or an algebraist. Uh, uh, didn't consider it to be a number at all. Interesting. I mean, I'd say 1 is the empty product, and so if you want your primes to be atoms and your numbers to be molecules, then 1 is the molecule that has no atoms in it, the empty molecule. Let's see, it's going to be hard to put a 5 on here, so we're going to have to put a 5 in one of these 2 cells. I noticed that. Let's see, what else do I notice? So we're going to have to put a 5 in this box in one of these 3 cells. That's kind of interesting. Yeah, people are looking at the Ren bonds, so because of the mirror, these are either both prime or both composite. And if you look at that, the interesting thing is that every pair or every Ren bond of length 2 has an odd and an even on it. Well, the evens are 2, 4, 6, 8. Only one of those is prime. And the odds are 1, 3, 5, 7, 9. And in fact, only 1 and 9 of those are composite. So we need to either pick prime prime, in which case one of the primes is 2 and the other prime is 3, or we pick composite composite, in which case 1 doesn't work at all. And so we have to get 8, 9. So these are indeed 2, 3, 8, 9. It took me a minute. I saw people say that, and it took me a minute to find a way to say that I was happy with. But I eventually found a way to say it that I was happy with. Yeah, I guess we do know that there's no 4 and 6 in here for what it is worth. Though, so there's certainly a 4, 6 in here. But both of them could be in here. It wouldn't necessarily be a problem. Let's see. What is left in this box? Maybe that is worth also writing in. Okay, well, the 5 in this box is certainly in one of these 2 cells. Those are the only 2 places it can be. But the remaining stuff in this box is 1, 4, 5, 6, 7. This one, of course, not being a 5. Let's see. Okay, so I guess we should do math about the diagonal, right? Because there's the same number of primes on both sides of this. There are, remember, 4 primes. So that means that there's an even number of primes off the diagonal, and there's an even number of total primes. So there's also an even number of primes on the diagonal. And so the question is, what is that number of primes? And so we're choosing from 1, 4, 5, 6, and 7. Oh, right, this one's not 5. I didn't take that. And so if that even number, oh, well, there's definitely 2, right? There's definitely 2, therefore, because 5 is on the diagonal conveniently. I didn't do that. And so therefore 7 has to be on the diagonal as well. So these are not 7. And 7 is definitely on the diagonal. So these are indeed both composite. I think Emily did that slightly differently, but that all works out. I do agree with Edwardle. 4 doesn't work goodly here, because if this is a 4, these are both 9, and that sees every place for 9 in the box. And now, funnily enough, we have a really silly elimination, which is that this digit can't be 1, because in both universes, either this is 1 or it's 6, and in both cases, that can't be 1. Because if this is 6, both of those are 1. So this is never 1. Oops, I did not then eliminate 1. Okay. So we have the littlest of Renbans over here. Oh, right. Laura reminds me that this is the most voted on puzzle, as I am always terrible at remembering myself. This is the most voted on puzzle. This was voted on by supporters. Screaming Ice Cube, David, Dorlear, Russ, Luda, and Doomdiot. So thank you all for your support. And speaking of, do please give the stream a like if you have not. I was today perusing what videos have gotten the most likes and seeing that there were a couple streams that only had 1 or 2 likes, and then realizing it must have been because I had forgotten to say it. Yes, this is part of a now 22-way tie. The tie is slowly decreasing, but there is still a lot of opportunity for people to go in and alter the course of history by voting for other puzzles. People who support at the windmill level or above get to vote on the puzzles that come up. I guess. Oh, I was going to say now this isn't 5, but that's not that. This is not that kind of diagonal. Okay, it's a 5 and a 7 and a something. Let's see. We're tied at 6 votes. We have 21 puzzles in the bucket with 6 votes each. Okay. This whole mess, because it's a square, we at the very least can pare this down to these numbers. But if we think about it, these are the same primalityness and the same high-lowity. So if they're low, they're 2, 3, because there'll be a 2 or a 3, so there can't be a 1. And if they're high, they'll be 8, 9, because 7 doesn't work. So these will always be from 2, 3, 8, 9. Now, interestingly, that means these can't be 7, because 7 doesn't go next to 2 and 3. These could be 3, actually. That would be okay. Yeah, I was hoping I'd get 1 more elimination, but apparently no such luck. That is true. There's always an 8 and a 9 in here, no matter what I do. Because I either use these as both being 8, 9, or these as being 8, 9. Yeah, so the short German whispers now is actually way more powerful than it looks. That's a clever setting. So the high digit on this is a 7 or a 6, which means this needs to have a 1 or a 2 on it. And so we've got sort of a virtual 1, 2, 3 triple between these. So there's a 4 over here. And the 4 goes with a 6 or a 7. Okay, so no 4 in this part. If there's no 4 over here, then that means that this Renbon is 5, 6, 7, 8, 9, which would force these to be a 1, 2, 3 triple in the column. Is that a problem? It doesn't immediately look like a problem to me. But it seems like it should be a problem, but I don't know yet. Okay, so we've got our virtual 1, 2, 3 triple. Oh, okay. Jay is looking at saying 1, 6 doesn't work because if this is 1, 6, then we need both of these to be composite, and that is a problem. Because if these are 1, 6, now I'm choosing these both to be composites from 4, 5, 6, 7 that aren't 6. So in other words, I'm choosing them 2 digits from the digits 4. And 4 is not enough digits to choose 2 digits from, so this can't be 1, 6. So there's definitely a 7 as the high digit living over here. And now the 5 can't be here because that 7 needs to be mirrored up here. And these can't be 2, 7 because there aren't 2 primes to put up here. There's only 1 prime. So in fact, we get that these are 1, 7, which peels 1 off of this. Yeah, Emily, I see, noted that that as well, which is very helpful. Okay, so these are either 8, 9, or 2, 3. This 1, 7 is kind of interesting. Okay, so now we certainly have that this Renbon is extreme because it can only have 1, 4, 6 on it, but it definitely needs a 4, 6 on it. So these are from 4, 5, 6 for sure. And these are either 1, 2, 3, or 7, 8, 9. And these are therefore either 1, 2, 3, or 7, 8, 9. And therefore, this digit is either a 2, 3, or an 8, 9. This digit is either a 1, 2, or a 7, 8, just to good lift that a little bit. I was hoping we could sort of force 4 6s around here, but I'm not sure that we quite can, as the case may be. Yeah, right. Lockie is right. This 1, 7 pair tells me this can't be 6, so it's a 1, and we get a digit. We'll bring out Zach for the 1 dance. Boop, boop, ba-doop. Woo! Ba-doop, ba-doop. Wah! Ba-doop, ba-doop. Wee! Ba-doop, boop, boo-da-boop, 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 boo-da-boop. Wah! Hey, Janine, how are you doing? Janine or Janine? Okay, so now we do have our 4, 5, 6 Janine. Okay. I thought that at first, and then I second guessed myself. Okay, so the 4, 5, 6 triple here tells me that that's a 7. I wonder if I could have gotten away without ever actually noticing that the 7 had to be doing here. Ooh, I have also played a good bit of Blueprints, and I think I'm going to be playing more of it soon because people seemed to enjoy watching that. Ooh, Super Mario Maker celebrity? Nice. I'm guessing that's what SMM stands for. Uh, okay, so yeah, so what color? So I need my synesthesia people in chat. What color is prime? Uh, uh, let's see. Then we can color. Yellow. Okay. Prime is yellow. And what color is composite? Hopefully no one says yellow. Are we going to make it like this grayish color? I usually use purple. Okay, we'll do purple. Okay. Yellow and purple is a good combination. Okay, so we've got one prime, one composite. Oh, okay, sorry. Two composites even. But yeah, I intend to play more. One isn't composite. That is true. One is not composite. One is a unit, so we need a color for units. But I don't think we should have a color for units. I suspect that will that will not end well. But it is true. One is actually a third thing, and then zero is a fourth thing. Very good spot from David. Right. Now we need a 1-7 here. And so in this column, and basically you can see this from this 2, 3, 8, 9 pair, that makes this a 1-7. It's a 2, 3, 8, 9 pair because I know these are either 1, 2, 3 or 7, 8, 9. Oh, I'm being told I know whether 4 or 6 is composite, even if I don't know whether it's 4 or 6. Interesting if true. Let's see. I know these are from 6, 7, 8, 9, and I know that one's not a 7. Funnily enough, these are all composite. So I actually know that this is composite, funnily enough. Hey, Panthera! Which is weird. So then this is therefore also composite or not prime or whatever. So it's a 1. Yep. So that actually sort of percolates. This is very smooth. Okay. So now we know that these are not 1, 2, 3. These are 7, 8, 9, which means these are 5, 6. Which means that that is a 4. Those are a 5, 6. This is not a diagonal. I cannot use the 5, 6 pair to see that. No matter how many times my brain tells me it is a good idea, it is not a good idea. Okay. So... Oh, yeah, I probably should fill in this, right? This is certainly not a 6. And 2, 3 is always prime in the same way that the one was always composite. So we can sort of yellowify that. Let's see. Is that getting us some sort of triple? Like if this was a 2, 3, then it would push this up very high. Oh, the other 2, 3 is also prime. A good spot. Let's see. This number is certainly larger than 3. So it's only 5 or 7. If you actually look at it. And in fact, it can't be 3 because there's no 1 there. And it can't be 7 because there's a 7 looking at it. So actually, it is just 5. Which gives me the 6 and the 5. The 5 being prime. The 6 not being prime. Okay, and so now 5, 4, 3. This is a 2, 3 now. And so that's a 4. And we should try to carefully reflect those, which I'm very bad at doing. I will warn anyone. By the way, this is not 2, 3 anymore, so these aren't 8, 9 anymore. So these are both prime. These are both composite. Okay, so the 4 over there lands there. Oops. Lands there if I reflect it, and the yellow lands there if I reflect it. Okay, so this is composite, so it's a 6. This is a 5, so it's prime. The prime bit reflects back over there. This is now a naked 3, right? Because this can't be a 4. So this is a 3, which also is prime coincidentally. So that's a 2, that's a 3, that's a 2, that's a 3, that's a 2. 4 only goes next to 9 on a German whisper, as has been pointed out. I don't know if it's true, but it sounds plausible. Yes, this row, Missing Deck points out, by the way, welcome Missing Deck, has all its yellows. So these are purple, but in particular, I know what this yellow is, namely it is 5. Hey, Playmaker! Okay, so those reflect over here. Oh, I guess that's just literally reflecting the fact that I have an oople. Okay, there needs to be a 3 in this column, and it needs to be yellow, so it's there. Oh, that was a weird lag. So then that's the 2 to finish over there. So these are a 1-9 pair, which I guess puts some interesting pressure on this whisper if you're into that kind of thing. Let's see. I feel like there's some stuff I haven't reflected yet. Maybe not. Okay, that's all reflected. This I haven't reflected. That gets reflected there. Okay, so this needs to be prime and therefore is 7. These are now both composite. That got reflected as well. Thank you, AFK. Okay, so maybe I should actually look at what this can be now. So it's not 1 or 9. It's not 6. It's not 5. It's not 2. So this is a 3 or a 4. Well, it's not 4 because there's no 9. So the low digit on this is a 3, and therefore the high digit is not a 7. So this is just a 3-8 pair, which makes that a 6, weirdly enough. That is incredibly strange. And these are a pair of some sort. The fancy among you will be able to tell me. Which are 4 and 7, I want to say. Okay. So all of that was good. Okay, this is a composite number that's not 4, 6, or 9. I'm just going to keep using composite incorrectly. So I think this can only be 1 or 8. Row 3 needs an 8 and a 9, I'm being told. Which are, in fact, and I could have even seen this, the 7s over here. So these are just both always high. Funnily enough, those 8 9s actually reflect to 8 9s. Oh, these are an 8 and a something. They're an 8 and a 6. So this is 5, 7, or 9. And funnily enough, of 5, 7, and 9, it can only be 7, which is yellow, which now sorts out this 1 and this 7. 1 is composite, 7 is not. Okay, so that 7 reflects over there, that reflects over there, meaning that's 5 and that's 6. I've got that digit needs to be yellow, which makes that 7 and that 4. Like that. Of course, 7 is the only option left that doesn't resolve the 6-8. Yeah, that's about how my luck has been going lately. Although, funnily enough, yesterday, my bad luck was that our air conditioning didn't work. And then today it just works, which is somehow like an odd combination of helpful and unnerving, we'll say. Let's see. 4. Oh, 4 just goes here. I realized David is saying, 4 is not prime in most strings. Let's see. Actually, I think you could argue 4 is not prime in any ring. It's irreducible in some rings. Uh, okay. Uh, 2, 3, 4. Okay, 5 and 9 are what is left. Let's see. These are a pair of some sort. Much appreciated ring theory commentary. You come for the Sudoku, you stay for the ring theory. That's what I always hear. It helps drive engagement if there is more abstract algebra discussion. To 3, 4, 5, 6 over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those are 1, 7, and 8. Not super helpful. I'm not 100% sure now that I think about it. It's possible that in the ring 4Z, if you define prime, that 4 is prime. I'm now not 100% sure. No, it's not, because it divides 8 times 8, but it doesn't divide 8 in that ring. Okay, so yeah, I think my claim was correct, that 4 is not prime in any ring, but we'll see. Is Mekti's point about whether 4 is prime in all rings or not? Oh, it looks like not. It looks like Mekti is doing Sudoku. Like, where's 4 in box 3? So there is a 4 here that of necessity goes with a 3 or a 5. And this is apparently only able to be a 4. Okay, so now, oh, sorry, I was going to say, so now the 9 over here. Going down the ring rabbit hole is always a good use of time, yes, although the problem with ring theory is if you do too much of it, you end up in commutative algebra, which I think is in the running for the ugliest area of all of mathematics, in my opinion. I say as an algebraic geometer, kind of, which is maybe offensive. Let's see. There's a 5 in one of these two cells, I see. They can't all be winners. I mean, I don't dislike rings. It's just let's see. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. No 6 or 7. Okay. Every ring comes with the Zariski topology, right? Okay. So we've got. If you've ever wondered what math grad school is like, it's just like these jokes for 6 years straight. Okay, 2 and 5. Okay, this is 4 or 6, I want to say, if I have correctly scanned all of my, I cannot tell you how many hours, we spent in grad school debating how one should decide which of two integers is more even. Okay, let's see. There is a... Oh, I was trying to say there's a 7 over down here by Sudoku, but that's not quite how the Sudoku works. Let's see. The diagonal doesn't have a no repeat rule. The diagonal only reflects primeness, I think. Though I will say to Achad and Missing, I have tried and caught myself trying to do Sudoku on this diagonal so many times in this. So yeah, like, which is more prime, 4 or 20? Or sorry, which is more even, 4 or 24? You know, it's hard to say because like 4 is 100% even if you want to think about it that way, but 24 has more 2's in it, but it also has the impure 3's in it. Okay, these are a 1 and 8. and a 2, I want to say. So these probably also have some digits in them. Does this 3-8 interact with this in some way that is compelling? Hey, Nell, how are you doing? Welcome to the only person who was ever impacted by the non-existence of orthogonal Latin squares of order 6 in a meaningful way. Oh, there are different numbers of colors in box 4 and box 6, I'm being told. Weirdly, pi is actually the most even number. I think all my coloring is reflected. I could be wrong. Now, it's very possible there's coloring I could do by looking at the candidates that I have not done. Row 7, column 6 sees all the yellow digits. Does it see? It does. Yeah, wow. Sweet. Yep. Haha. So this is composite. Excellent. I always love those points. Okay, so now this is not 7. It's 1 or 8. Let's see. What is this? Okay, so this could be 4. It can't be 6 or 8, and it could be 9, I think. There's a 3-8 pair is why I said it's not 8. I know, I'm as amazed as you that I saw that. What more could you want than a cell being a hidden composite? I don't know what more you could want out of a puzzle. Okay, so the 3 and the 8 are obviously in different rows. So I have a 3-8 going vertically in this, not horizontally. Okay, so if I make this the 3-8, then that's the 3. If I make this the 3-8, I don't think that quite breaks. I was looking for some like weird tricksy, because of the verticalness thing, we get a thing, but I don't think that because of the verticalness we get a thing. Should we good lift this? Sure. I can do that. Okay, so 8, 7, 6, 5, 4, 3. Okay, 1, 2, 3, 4, 5. No, can't be 5. It can be 6. Okay, so 6, 7, 3, 4, 5, 6. Not a 5. 2, 3, 4, 5. Not 3, 4, or 5. 1, 2, 3. Okay, so there is our good lift thing. The 2, 9 are vertical is the problem. Someone yeah. Okay. Yep, that does it. Okay. Yep. Nasty. I even looked for this deduction and I didn't see it. That's how you know it's cruel. So 2, 9 does not work in this column, and 2 and 9 are in the same column because 3 and 8 are in the same column. Admittedly, I also like the adding one more layer of obfuscation by not using the fact that the 3 and 8 are in the same column, but rather that the other two are in the same column. Often that's sort of like how good puzzle setting goes, is like finding a deduction and making it just like one step removed. But anyway, that's quite satisfying. These can't be 2, 9, so they're not. So these are 2, 9 and 3, 8. And so that gives me the 6 and the 8, which gives me the 4, it would seem. This seems to be 5 or 9. That 2, 9 does look down this column. Purple. 9 and 5. So this can't be a 3, for example, I see on the thermo. This isn't a primality deduction, but it's true. If this was a 3, that would be a 6, and that would break that. So this is never a 3, which I thought was going to give me a 1-2 pair in the column, but it turns out that's not how numbers work. My reflecting reminder has told me that I should reflect, I think it's these. So I think this one is composite. And this one is prime, so that's going to, I think, sort out this whole mess. Okay, so these are both going to be composite. These are both going to, sorry, those are both going to be prime. These are both going to be, no, those are both going to be composite. I said the right thing, and then I picked the wrong color, and then I changed every combination to just make it worse from there. We got there eventually. I will accept no further discussion of the coloring of box 1. Okay, so we will make that not a 2. Okay, let's see. It was pointed out a minute ago that there was something wrong with this being a 6. I was trying to go back and understand. Oh, it breaks. Oh, right. Sorry, it's much easier than I thought it was. If this is a 6, this is a 7. Sorry, I was trying to like use this 8, 9 in this row or look at something. No, if this is a 6, that's a 7, and those don't mirror right. So, so this is a 2, which makes that a 1, which makes this yellow and this purple, which makes this yellow and this purple. So this is at the very least not 6. And this is the very least not 7. And this is at the very least 8. Which seems to make this a 1 and this a 2. Seems to make that a 5, which makes that a 5. We need one more even on this diagonal, because remember, we need an even number of primes on the diagonal of every diagonal box. So there's one more yellow in one of these two cells, which means these are both always purple. So that means these are both yellow just by yellow doku. So these are 3 and 2, and we know the order. This is a very nice puzzle. I agree. I swear I pressed 2 and it maybe entered a 2 in a random spot in the grid, but not where I wanted it. These are now both purple for lots of reasons. And one of them is a 1, and it's that one. The other is a 6, so it's that one. Let's see. We need a 7 in here somewhere to be determined. Let's see. Can I do some reflecting? I bet I can. Because I bet now that's yellow, and these are purple, if I reflected that correctly. I'm always scared to use the reflection, because I have a bad habit of reflecting badly. Okay, so now that's yellow, and that's purple. I wonder if this was set without a solver, because it feels like this would be very difficult to set without a solver. Or I suppose a solver, or the alternative for a solver, a giant amount of patience. Okay, so this is 4 or 9. Just by the row, sorry, 4 or 9. If this is a 4, it would make that, right. So this can't be 1, 2, or 3, so that can't be a 4. Okay, so now this number has to be less than 9. We'll keep that in mind as we work through this. Okay, this finishes where the 7 went. So it looks like we've got 6, 8, 9 left in here. Uh-oh. No, we don't have 9 left. We have 6, 8, and the other one left. The other one is 4. There we go. That is a 4. That is an 8. That is a 6. I'm not sure. Maybe there's a 4-9 deadly pattern, maybe, that needed to be sorted out. That is purple. That is yellow. That is a 7 and not a 2. I was going to say it was a 2. It wasn't a 2. It's a 9. There we go. Very nice. Very good setting there. I'm going to take a oh yeah, the make a cool puzzle, but the solver tells you the board is invalid or it has 8 solutions. I've definitely had that happen. And I've definitely also had puzzles where I didn't have a solver, where I worked on them a long time, and then it turned out that actually I could prove that it was not possible. So, the setting without a solver is scary if you have a global constraint, and this is exactly the kind of global constraint where you get screwed at the very, very end of the thing. All right, I'm going to take a quick stretch, and I'll be right back. But while I do that, please hit the like button on the stream an odd number of times total, and convince your friends to do the same. And I'll be back in just a moment for more puzzles. See you in just a bit. Hello and welcome back. We've got a puzzle with 10 lines and German whispers and Renbon, so good combination. And a given digit, so we appreciate that as well. Also what looks like it's going to be the Fistomophelius puzzle, but I doubt it is, but who knows? We'll find out. Oh, wow. Is this what Simon did today? Amazing. Yeah, so amazing. Well, I'm going to do it anyway. But that is very funny to me. Yeah, I was looking through the Discord puzzle archive, which has the problem that it is basically unviewable in any reasonable fashion. But I was looking for it for puzzles for the Invitation to Sudoku series. And as I did, I stumbled across a few puzzles that I looked at and was like, well, this is not an invitation to puzzle, but this is a zetamath wants to do it puzzle. So so that definitely got some things scraped in there. All right, so I suppose we get to start with our 5 dance because we cannot place a 5 anywhere along a German whisper. So we will bring out Zach for the 5 dance. Ba-boop-a-doop. Wah. Ba-doop-a-doop. Wee. Ba-doop, boo-doop, ba-doop, boo-doop, boo-doop, boo-doop. Wah. Thank you, Zach. Thank you. And so these are a 4-6 pair, which indeed do form a 10 line. I can confirm. And so then these are a 1-9. And then these are going to be a 3-7 and a 2-8. We absolutely need a 5 dance emoji. We should be able to do that. I think that is possible. Okay, these numbers are all at most 7, because this is a 3-cell sum to 10. That one's not 5 at least. That one's not 5 either, for what it's worth. Yeah, I guess there's a lot of these, aren't there? Okay, so these 10 lines in this corner, these can't be high. If they were, it would not work. So these are low and these are low. And so these are high. And they can only be 7, 8, 9 as a result. These sum to a maximum of 7. So these are this is at least 3. That's true. 7 breaks the 10 lines. That's very true, because if this is a 7, it forces these to be 1, 2, which makes that be a 7. So no 7s there. That's a very cute setup there. We can rule 6 out of this cell, Ron points out, because if this were a 6, that would be a 1, and this would be a 1, 3. And that's too many 1s for a single column to have. And likewise, this can't be a 7 for the same reason as up here. If this was a 7, that would be a 1 or a 2, and these would be a 1, 2 pair. So in fact, this is definitely low. This is definitely high. Right. There can't be all numbers that are from 1, 2, 3, 4. This requires more math. You can't have all numbers that are 1, 2, 3, 4 running along a 3-cell 10 line, because the sum will be at most 9. So these can't actually be 3 or 4. They're always from 5, 6, 7. I think David is telling me this can't be 415, but I'm not sure I see why. As of yet. Because there's a 4-6 pair in row 6. Okay, this isn't a 2, by the way, while we're marking things. Okay. So we've got all of that. Annoyingly, this is an 8, 9. We might be able to. Okay, where am I? So this 8 or 9 definitely goes in one of these cells, making it part of a 2-cell sum. But I think I don't quite have enough, despite having this 2-8 that's saying that if it's an 8, then I either go 2-8 there or 2-8 there. But I don't even quite know that the 1 or 2 lands in this box. Uh, uh, yeah, the total of the corners is definitely a multiple of 10. This one just is always a multiple of 10. That's a multiple of 10. That's a multiple of 10. That's a multiple of 10. And so what I get is that these highlighted digits sum to a multiple of 10. And so these have to be either 1, 2, or 6, 7, because they have to add 2. I guess they don't have to be 6. They have to be 3 mod. Uh, yeah, I guess there's no other sum to 13 that would work on a Renbon of this length. So these are from 1, 2, or 6, 7. What I used there, by the way, if you've not seen this before, is that all of these digits are, for Sudoku reasons, identical to these digits. And I know that the digits in the center are sum to a multiple of 10, and so we can just sort of throw away multiples of 10 until we're left with just these cells. So that gets us the 1, 2, 6, 7 business that we have over here. So interestingly, if this is 6 or 7, that's 1 or 2. So there's always a 1 or 2 in these cells. Yeah, this could certainly be marked as 3, 5, or 8. And it's not 5, I guess. It's just 3 or 8. And so this cell is just 2 or 7, if we look at it. So that's a virtual 2-7 pair, because I need a 2 or a 7 in here. And so, right, because this can't be 1, 6. Yeah, I need a 2 or a 7 in here. So that's a 2-7 virtual pair. So that means that's not 7 at the very least. Oh yeah, this is just never 6, because 6 doesn't go opposite 2 on a German Whispers. And if this isn't 6, that's not 7, because remember, they sort of went together. Let's see. Right. This just can't, neither of these can be 2, in fact, because if either of these were, oh, no. Sorry, this is not a German Whispers. That's the German Whispers. Uh, uh, yeah, okay, so this can't be a 3 because of what it would do to column 9, is what Ron is saying. Because there's at least 2 1, 2, 3, 4s in here. If there aren't, then it sums to at most, or at least 1, 5, 6, which is 12. So there's 2 1, 2, 3, 4s in here, 3 of them here. So there's only 1 1, 2, 3, 4 left. That means I can't make this a 3, because that would make this a 3 and a 1 or a 2. That would be too many in the column. So this is an 8. Good spotting to Ron there. So that's a 6. That's a 7. That's 2. Which has made that a 9 and a 1. Which has now unwound the entirety of this box. Like that. So now no more 6 up here. No 1, no 2, no 3, no 7. Okay, so this can't be a 2 because that would need to be a 7 and it can't be. This can't be a 7 because that would need to be a 2 and it can't be. So that's a 4 and that's a 5. Just made that a 7, a 2, and a 1 up here. This is the other thing. It's a 3. Uh-oh, what did I do? Row 6. I don't know why I think that 9 only goes opposite 1 on German Whispers. I don't know. Because our air conditioning was out yesterday. I'll blame that. Okay. Yeah, I was actually thinking like yeah, that seems like way too much for the puzzle to collapse at once. However, there has to be a 7 in here. Oh, 7 or 5. Sorry, there has to be a 5 or a 7 in here, I guess, is the upshot of this. So there's a virtual 5-7 pair in the column. So this digit is not all that many things. Yeah, right. We need the 5. Yeah, we've got the 5 or a 7. So this is always from 1, 2, 3, 4, if you want to do it that way. I said it with such confidence. That just comes from being a professor. I have to say wrong things with confidence, or they won't pay me to teach. I could say right things with confidence, but that seems like it would be even more expensive. The 9 on here would need to go with a 1, but I don't necessarily see that as a problem right away. So now we're counting. I'm trying to think of the elegant way to do this that isn't horrendous. Counting highs that end up on the Fistema-Fel ring. So how many cells are on the Fistema-Fel ring? Looks like 16. So therefore, what people are using is there's at most 8 highs on the Fistema-Fel ring, because if you put more than 8 highs on the Fistema-Fel ring, then you end up with too many. It's going to be heartbreaking if this Fistema-Fel ring breaks into 8 2-cell tensums, though. So let's count. And the same thing applies to 5s, in fact. So that would be 1, 2, 3, 4, 5, 6, 7, right. And so if this splits, it'll be 8, 9. Heartbreaking. So this can't split, because I would put 9 digits that are at least high. Well, you can't do 5 5s as a 10-sum, and you can't combine 5 with another high number. So yes, we can count 5 as high. This is 1, 2, 3, 4, right? So there's a 9 over here. Let's see. You agree, right, AFK? So we have 7 high digits. Okay, it's definitely not 4 pairs. Yeah, right. When it was 7 highs, yeah, there's 7 highs, right. It was the fact that we'd spill over by 2. It's not all dominoes in the ring because we have 7 highs. So we can have 1 5 on the ring if we would like. If we're into that kind of thing. A 1 3-cell segment doesn't work because there's 16 cells. So we have to have 2 3-cell segments. Or 1 4-cell segment. Maybe there's a 4-cell segment with a 5 in it. If that's true, I'll be really happy. So there's a crazy thing I think people are saying that happens if this is 2 3 5. Not sure. Okay, there is a 9 on the Fistamafel ring somewhere. It's not in any of these cells. Okay, I know there's 3 lows gone in this column, so this needs to have a start at a number that is at least 4. It's not 5. That one's not 4 or 6, actually. Just because of reasons. Oh, people are doing the 23 plus 10 is 33. So these add to 12. Kind of business. But these two don't add to 10, Paul Fly. These 3 add to 10. Oh, so you're just saying I can eliminate 2 from this cell. Because if this cell is 2 or 1, then these sum to 10 or 11. I see. And so this is a 3 or a 4. And this can only actually be a 1 because if these add to 12 and these add to 10, it means that this digit is 2 more than this digit. Right? Is that how that math works out? Let's do the math again. 10 plus 23 is 33, so these add to 12, whereas these add to 10. So therefore, this digit needs to be 2 more than this digit, and the only combination that works is 3 and 1. I think that works. I think that's exactly what Paul Fly was saying, isn't it? So anyway, so that's 2 and 5. Uh-oh, that doesn't work. That's broken. Right, this is the one that's bigger. Okay, so we get all of that. I'm sorry, Zombie Hunter. That one is my fault. So there's definitely a 1 in there. Thank you, Zombie Hunter. Thank you. Um, yeah, so this just works out either way, and it's fine, is the short version of all of this. That's not a 1 anymore. I'm sure that doesn't matter. Uh, uh, I think Sudoku Maker has a thing where you can pay to get them to add constraints to it, and so people do that, and so there's some random constraints in there. I think that is what happens, which is, it's a fine way to make money if that's what people want. Uh, uh, yes, right, right. Just by virtue of the fact that now this isn't a 1, so uh, I could be wrong. That's what I think someone told me, but I might not be right. Um, 4, 5 left in box 9. Yeah, we can fill in the 1, 3, 4, 5 over here. Yeah, one of these is 1, we know. So if there's a 9 in this box, it's exactly here. No, there can't be. That's clever. So where is 9 in this box? I contend it can't actually go anywhere on this line. Because if it went here or here, it would need to go next to cells that can't be 1. And if it were here, it could go next to a 1 there, except that would be a 1. Oh, no, that's okay. Sorry, if this is a 1, that's okay, because this, again, doesn't have to be 1, 9. Uh, uh, yeah, the problem with implementations of 10 lines is you have to be smart about it, because you can't do an exhaustive search, or it will just become crippling. Which is the same basically as region sum lines. Region sum lines, if you've ever played with a solver, then region sum lines don't really work out well in these things either. So 9 is in one of these. I'm trying to avoid things like this can't be a 4, but I guess we can do it if we have to. It would have to go with 1, 5, and it couldn't. Yeah, we definitely need to have an 8 or a 9, and I thought I'd proved it had to be an 8, but I had not successfully proved that it had to be an 8. Yeah, and it's that 8, 9 for whatever that is worth. Let's see. I like the solver for is this broken, particularly at the beginning. And if you're doing that with region sum lines, if you have a grid that's mostly blank, except it's got some region sum lines in it, you will frequently destroy the world before you can find out whether it's broken or not. But the good news is it's usually not broken. Because region sum lines, it's hard to break a puzzle with just region sum lines if you avoid things that would obviously be broken with region sum lines. Uh, uh, the 10-line implementation? There's not a 10-line implementation in Sudoku Maker, right? Or is there like a secret additional place where it has been implemented? Uh, So how many should we be thinking about? I kind of hope not, but should we be thinking about what exactly the thing is? So we know the 9 that's on the Fistamafel ring 10 line. It has to go with a 1. There's 2 8s. One of the 8s can go with a 2. They could both go with a 2, or we could have like an 811 somewhere in there, perhaps. Yeah, Zombie Hunter. We did sort of say there's either one 4-cell sum, or there's 2 3-cell sums. Uh, why aren't these actually in Sudoku Maker then, Paulfly? Uh, let's see. Some Doku-friendly night puzzle. So there could be a 7 in here. Let's see. We know there's certainly a 3. I mean, it seems very useful to have as many 1s as we can squeeze onto the Fistamafel ring, doesn't it, Ron? Like, it strikes me that this might have to be a 1 if we thought carefully enough about what the combinations are. I will have to have a look at that. AFK, that sounds interesting. Uh, uh, this 8-9 in column 1 is actually kind of interesting. If it's a 9, it can't go there. Yeah, the 9 goes with a 1. That's what I started with, is we know the 9 goes with a 1, but we don't know the 8 goes with a 2, because the 8 could go with a double 1 if it does it creatively enough. Uh, uh, let's see. AFK wants to count highs in column 7. We've got to put a bunch of them in column 7 somewhere. Uh, uh, so we're not counting 5 as high. Is the thing. Uh, yeah, so if we don't count 5 as high, and we ask about 6, 7, 8, 9s in this column, they can only go here. Isn't this fine? I don't see what's wrong with this immediately. Uh, uh, for squeezing 3, 6, 7, 8, 9s into this column. Yeah, it is tricky to argue how many, like, you can't put too many highs on a 10 line, but if the 10 line bends at all, you can do way more gymnastics with it than one might hope. Uh, oops. Uh, yeah, so I see this can't be a 2 because of a chain leading through box 3. Uh, which is kind of ugly, but I agree with it. If this was a 2, it forces both of these to be 5 at the end of the day. It's pretty horrible. Uh, but it's true. Uh, let's see. We know there's, in fact, exactly 1 8 on the Vistamafel ring. That's the sort of the interesting one. Three, 2, 5, 7, 2. What's wrong with the 3? Okay, I will confess here that I have tried to set a puzzle with this exact 10 line like 100 million times, and every time I've tried it, it has worked out to be horrendously messy. And I had hoped in seeing this that someone had figured out how to do it without it being horrendously messy, because I have wanted that. I think this is just horrendously messy. Uh, in for my personal taste of these sorts of things. Uh, I will go ahead and mark these. Uh, let's see. Can I do anything easily around here? Uh, yeah, there is a 2 in here. We know that because we've got a 2 down here. Uh, do you know it's not 9-1 here? That's the combination that has happened every time I've looked at it AFK. Uh, that has stopped me, because that was the first thing I tried to look for, was to try and figure out where the 9 could go. But I think unfortunately we've got enough. Uh, and I even thought I'd proven that this couldn't be 9 when I saw it would make this be 2, but I don't think that's how math works. Unfortunately. Uh, oh yeah, you're not responsible for every word I've ever said, I promise. Uh, I say a lot of words. Hmm. And unfortunately, Nicholas, that's just a very easy thing to do. You can put three ones on a 10 or in a giant 10 line very easily. Uh, like it's just not restricted at all. Uh, I am a bit interested in threes though. Uh, but I'm afraid that is not very restricted either. Uh, yeah, two 3 cell segments just leaves you a lot of room. Uh, I do agree, none of these are one, but we've still got sort of 3 houses to put ones in. Yeah, we've got these two definitely show up here just because of that. Yeah, I noted that before, which I had hoped would do something, but it had not obviously done something to me. Uh, okay, so Paul Fly has come up with the idea that maybe we should color this Whisper in box 5 and actually look at what some of these combinations look like. And so if this is 1, for example, it means that purple is high. Uh, and so if this is 1, then, for example, this isn't 7. Uh, and so, therefore, this being 2 just doesn't work because this would go 2, 1, 7. I maybe wouldn't use the word cute to describe that, but I agree it is true. That is as far as I'm willing to go in the positive adjectives list. But it's very possible that I'm supposed to think more carefully about this. It just seems so poorly aligned to do that. Like I kept trying to use like this 2-8 to say something about where the 8 goes because it sort of says, oh, you can't have a 2-8 domino here, and so then that sort of seems to put some pressure on the 8 in column 7, but it doesn't quite. And likewise, sort of around the grid, it sort of feels like everything is just a little too slippery. Uh, but the 8 in column 7 is something I spent a lot of time in this puzzle thinking about, but I haven't gotten anywhere with it. Uh, I guess the annoying combination is exactly that these could be 2-8. Because it's actually gotten a little bit better now than it was last time I thought about it. So if I'm going to put an 8 in this column, if it's not going in this box, then it's going in this box, and it's going with a 2 that also goes in this box. Oh, let's see. Playmaker says this can't be 2-8. Oh, God. Playmaker has a horrible argument, which is that if I do try and put the 8 here, it goes in these cells exactly because of that 2-8 domino. So this becomes a 2-8. And then you can now say, okay, well, now there's not a 2, or there's not a 2 over here, so there's not a 7 over here. And so that digit is 7. But now, what am I doing with it? And the answer is, well, this 7 has got to go with a 1, 2, or a 3 here, and it can't be any of them. So it's pretty hideous. But the 8 in this column now goes up here, so that's a 9. Yeah, I sort of suspect, maybe I'll be proved wrong when I go watch Simon solve this later, and he did something amazing. But I sort of suspect this puzzle was I want to draw a 10 line here because it is pretty, and then I'll do what I have to make it unique, rather than I have a really beautiful thing to do with this 10 line wrapped around this sort of puzzle. So 8 here could go with a 2 there, I want to say. So now, though, we do know there is a 9 living in these cells. The 9 certainly goes with a 1, and the only place the 1 can go is here. So we get our 9, 1. And so that is one grouping. And so then we can fill in this box. I am really impressed Playmaker spotted that. Requires a strong stomach. I'll say that. So then we go 2, 4, 5, 1, 7. Okay, so now this digit's always even, so this digit's always odd. So it's a 5 or a 7, going with a 4, 6, or 8. Okay, so if this is anything, if this is a 2-cell sum, it's 4, 6. And if it's a 3-cell sum, well, sorry, I should say if it's a 3 or more cell sum, I don't think it works because I've got to get like I can't make these 2, 3, 4, right? Or 2, 3, 5, right? So basically, if the sum extends more than 2 cells, I have a problem with these 5 cells collectively, which is that they're all from 2, 3, 4, 5. And that's too many 2, 3, 4, 5s. So, in fact, this does split here, and this is 4, 6, which makes that 3, 5, and makes that 4. Let's see. These are a 3, a 5, and an 8, which makes that a 5. Makes this 2, 3, 4, 5. Makes this a 6. This isn't a 5 anymore, so this isn't a 4 anymore. So this isn't a 3 anymore, it's a 1. So we've got our 1s looking up here, if you're into that sort of thing. So we know there's a 1, in fact, exactly there. Just by math. Let's see. These are 2, 3. No, not 3. 2, 6, 7. No, not 6. 2, 7, 8. There we go. 2, 7, 8. That one's only 2 or 7. If this is 8, it breaks right away because now I've got to put a 1 or a 2 here, and I can't. And I don't even have to think about it more deeply than that. So that's the 8. I can't put a 7 here either, because if this is a 7, I need this to be a 1, 2, or a 3, and it can be none of them. So that's a 2, that's a 7. Okay, but now we don't quite know what's happening. That was definitely my favorite spot or part of the puzzle so far, was that 7 didn't work here because this couldn't be 1, 2, or 3. There is an 8 in these cells, though. It's not there. Just by Sudoku, there's an 8 in these cells. There's also a 1 in these cells, so it's in one of those two. So one of these ones needs... Oh, sorry, no. I was going to say one of these ones needs a 9, but no, we've already got the 1, 9. Oh, right. If I have a hard time putting this 8 with a 2 because of that 2 still being in there. So yeah, the 8 just has to go with a 2. And that wasn't interesting to me, but the problem is the only 2 I can put the 8 with is that one. Okay, so that is that. Okay, this probably isn't 1, 9. Because, in fact, it's definitely not 1, 9, because I've exhausted my 9s on the Fistum of Fel ring. So this is either 2 or 3 long. Could be either. Can there be a 7 in here? I don't think so. No, there cannot be a 7 in here. Oh, yeah, I guess that's the question. That's the easy way to do it. Chad has it. What's the minimum, given that it's not a 2-cell sum, what's the minimum these 3 can sum to? And so the answer is if they're 1, 4, 5, and that does sum to 10. Okay, thank you, Chad, for making that less painful than what I was about to do. So these are, in fact, 1, 4, 5, and they are a 10 sum. We know that's not the 1, that's not the 4, that's not the 5. So these are a pair, which includes a 7, by the way. So that's a 6 and a 3. So no 6 goes there. No 6 goes there. These are 7 and 9 now. No 3s over there. There is a 5 in this column now, so none of these are 5. So there is a 5 over here for sure. Let's see. Right. This now has to be a 3-cell sum because we said, remember, there's sort of 2 quote unquote extra cells. And so we had to either have 2 3-cell sums or 1 4-cell sum. We now know we've got 2 3-cell sums. This has to be it. And so the entire rest of the split is just forced. Yes, by pure coincidence, this is the same puzzle Simon did today. Ooh, excellent, AFK. I thought was that J Sums chaos construction really 9 months ago? I feel like I just did that. I'm trying to see how diplomatically I can say that I don't, strictly speaking, agree with Playmaker here. But let's see. So we've got a 4 and a 5 up here. Sorry, we've got a 4, a 5, and a 2 up here. These, therefore, there's a 3 in these cells just by Sudoku, so they have to be 3, 6, and we know the order. 8, 3, 4, 6. 7, 8, 9. So that is a 5. Oops. Ah! That's not what I wanted, pen tool, and you know it. But it's okay. You know I love you more than anything. 5 and 6. 7, 8, 9. 7. except for Tristan, of course. Uh, uh, and Christian and Kai, all the others. But, 2, 3, 4 goes there. So that's a 3 and that's a 2. 5 and that's a 3. There's no 2 there. Okay, this is a 2 or a 3, and it's a 2. So 9 and a 7. These are whatever's left in the row, which are a 3 and a 7, it would seem. We even know the order. Okay, well, the challenge remains. Make a puzzle that Zeta likes that has a 10 line in this shape. I've tried it so many times. It feels like it should be possible to have some nice logic with it. Maybe it's not possible. But it feels doable to me. That's a 5-6 pair, which makes that a 1 and a 4 and a 5. Uh, 6, 1, 9, 4, 5. Voila. Well, I'm curious. I'm going to skim at least Simon's Solve later and see if there's something we missed that got us through that. Because there were, like, even to get to Playmaker's spot, which was particularly gnarly, we had to make several other gnarly spots along the way. So I'm not sure, but it's very possible there's something that we just didn't see about figuring this out. Because it sort of felt like, oh, there's this Fistamel stuff that did interesting stuff, but then it didn't actually get us anywhere in the solve, and then it was only marginally useful. So it seemed like there was a lot of really neat opening stuff that then sort of spiraled into other stuff. Anyway, I'm going to take a quick break. We'll be back with another puzzle. Be right back. Alrighty, welcome back. Uh, Let me guess, I pulled this up just in time for it to turn out that this is what Mark posted that he did today, but we'll see. Uh, but we have uh, 17 with a purpose and direction by Sudoku. Uh, we have killer cages. Digits in a cage cannot repeat, and they sum to 17. That is it. Uh, yeah, I have been sort of varying the titling, uh, the Zeta titling method lately, because there's this whole like year, uh, it was like last year or maybe the year before that. There's like this year period where people talk about like my puzzle and they're like, oh yeah, the like incongruity or whatever, and then I'm like, what on earth puzzle was that? And then I go back and I'm like, I don't even really remember setting this, so I've been trying to go for more evocative names, at least in my inner mind. I don't know why. It never used to happen. It's not like I've ever done titles that were anything but like one cryptic word, but somehow like bounce. I know exactly what grid it's talking about. But like I hear drift and then I look it up and then I'm like, I don't even remember this puzzle. I don't know. Maybe part of it is that some of it's stuff that I said on stream, and the stuff I said on stream goes faster, so it sticks in my brain less. That's very possible. Anyway, so as people in chat are saying, one of the keys to the world is that a 5-cell 17 cage always needs a 1, 2, and 3. We can keep that in mind with cells that see the entirety of a 17 cage. In particular, probably the correct place to start is to ask where we're putting 1, 2, 3s in these places, because we need 2 1, 2, 3s. Here. Oh, and actually we can also do a similar trick with these, where we also need 2 1, 2, 3s. And so this one's even better, actually. I need 2 1, 2, 3s in green. Well, I'm putting at most 1 1, 2, 3 in these, so these have to be 1 2 3, just straight up. Hey, Garion, how are you doing? Now, here I need, in these yellow cells, it's worse. I need to have a total of 6 1 2 3s. And so here we have to do the, like, I don't know, people call this like mutilated X-wing logic or whatever. Basically, you have to think about box 5 has at most 3 1 2 3s, and column 5 has at most 3 1 2 3s. So I can't make either of those cells 1 2 3. And basically the point is I need to have a 1 2 3 3 1 2 3s in these cells, and I need to have 3 1 2 3s in these cells in the column. I'm not going to mark that, but remember that we need 3 1 2 3s in these cells in the columns. Now, that's also a good point worth noting, is that the yellow 17 cages can't be the same 17 cage, because then I would have a sextuple of that value. So therefore, this cell and these 2 cells actually see all of the digits that go in every 17 cage. So these are these are all from 8 or 9. So we've got all of that. Okay, can this cage possibly have no 1 2 3s? I guess there's 2 cells in it that could be 1 2 3. Okay, so people are looking at what this sum is. So the whole row sums to 45, and these therefore sum to 11. And so 9 can't go here, so this is an 8. Very cute. So let's bring out Zach for the 8 dance. Ba-boop-a-doop. Woo! Ba-doop-a-doop. Wah! Ba-doop-a-doop. Wee! Ba-doop, boo-doop, ba-doop, boo-doop, 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 wah-ha! Ba-doop, wah-ha! Thank you, Zach. Thank you. So there is a 9 and an 8 over there. These are a 1, 2. So those are a 1, 2. I could just get rid of the 1, 2 corner marks, and I can remove the 3 corner marks from here. Okay, and I can mark both of these as having neither 1 nor 2 in them. And therefore, this is 3, 5, 9, and this is the other one, 4, 6, 7, which does indeed sum to 17. Good. Okay, so this cage, or this 17 cage... oh, interesting. I was noticing there's a good deal of overlap between these. Which is interesting. Yeah, that doesn't have an 8, though, so that's an 8. I agree with that analysis. And likewise, it doesn't have a 9 either, so there's a 9 up here. You like that? I kind of like that. And so that's a 9 as well, if we want to do that kind of thing. This isn't a 3, because there's a 3 in the box. So one of these is a 3, and therefore one of these is a 3. Remember, these are an authentic 1, 2, 3 triple, even though they don't look like it, because we know there's 2, 1, 2, 3s in green. Okay. So this 17 cage doesn't have a 3 in it, which removes all the options in the world. There's only so many options left. Now we could just pencil mark it with the remaining 15 options. Sounds like a good idea to me. Let's see. This 1, 2 is down here. And I guess I know these are from 4, 5, 6, 7. It's not the best deduction that I've ever made in my entire life, but it's true because these are each one of the distinguishing elements of the 17 gauge. I keep thinking about the overlap between the 4, 5, 6, 7s and these. And I could just squeeze a 5 here. I definitely have to fit a 4, 5, 6, 7 down here, so this 17 cage can't be 4, 5, 6, 7. That's right. I just said this 3-cell 17 cage is not 4 digits that don't sum to 17. You're welcome. I guess I know there's an 8 over down here. Not over there, so I can sort of force the 8 up there. Let's see. But what if it was, though? What if it was? Let's see. What are my options with 8s? There's some of them. Can't be 1, 2, 8, though. I can prove that. Eckbert believes Tristan solved this puzzle. These things happen. Let's see. If there was a 5 in here, it would land a 5 in there. I guess that's not a super impressive statement. You can confirm that these things happen. It's better than when Zeta solves the same puzzle twice. That is better than when Zeta solves the same puzzle twice. Uh, hey, one of the times that happened, it was because the grid had been rotated 90 degrees, and you can't expect me to rotate a puzzle when the grid has been rotated 90 degrees. Although the better one, I have to say, was the Star Battle by Bence Jofel that I think I solved 2 weeks apart, and I think the solve path was completely different both times, and I only really believed it was the same puzzle after checking at the end because it was almost identical. Or sorry, because it was different. Right. This digit is not 1, 2, 3. So it's 4, 5, 6, 7, 8, or 9, but you see this 4, 6, 7 triple in the box, so it's not one of those, and you also see the 8 in the box, so it's not one of those. So this is a 5 or a 9. Uh, huh. There is a 1, 2 in one of these cells just by Sudoku, but I don't know what to do with that. Hey, Ambrose, how are you doing? Winner of the longest solve on Invitation to Puzzles so far. Though it was like really the perfect puzzle for like me to like start doing it and then not give up, because I felt like it still taught very accessible ideas just in a way that took me a while. Uh, Commando Ambrose. Uh, Tristan solved it. Okay, good to know. I will. Well, I'll let people vote after the solve as to whether we take it out of the bucket or whether we leave it in and go for a threefer. Because we probably could. Uh, yeah, this one too we know is in there. So these cells aren't 1, 2, I guess is the craziest deduction ever. Like none of these are 1, 2. None of these are 1, 2. Right? Because yeah, these cells see a 1, 2 pair, and these cells see a 1, 2 pair. That's the question. Where do these 1 and no? What? I feel like I'm crazy. I feel like I'm proving something that's not possible. Oh, it's because it's right. It's only true for column 6. It's not symmetrical. That's the problem, right? In this column, I say, yes, this cage contains this 1, 2, so therefore these cells see the same 1, 2 twice, whereas these and these aren't 1, 2. So we can mark them as being from 3, 4, 5, 6, 7, 8, 9. And these it's even better because they aren't 9. So that's practically done at this point. So like if you consider that these have to sum to at most 7, or at least 7, it means that each of these digits is at most 10. It is true they also see 3. That'll make that deduction even better. Because there's definitely a 3 in here, and wherever it is, this sees it because of that not being a 3. So we can click out the 3s there. So now these sum to at least 9. So now these need to sum to at most 8. And so if I fill these in, now I know they're just from 1, 2, 3, 4, 5, 6, 7. Except I know these two, or sorry, that one I know can't be a 1, 2, or 3 because the 1, 2, 3 in the column are there. So actually, these cells now are a minimum of 4, 5, 6. Which is already 15, which makes this a 1 or a 2 always. And so now that 1, 2 is the same as that 1, 2 for what it's worth. So we get our aforementioned coloring of 1, 2s. Oh, I'm being encouraged to contemplate where 9 goes in this column. Now the 9 goes here. Wait, is what true? Did I screw something up? Oh, maybe it's not the same one, too. You're right. Uh, that's possible. Because these could be a 1-2 pair. It is still true that this is a 9, though. Which means there's a 4 or a 5 in here. Okay, so this is not a 1, 2, 14, 17 cage, we now know for sure. Okay, so this, if we now look at it, because the minimum is 4, 5, 6, we can do some squishing around if you want. Because the minimum is 4, 5, 6, which is 15, plus 1 is 16. That means I really only have 1 degree of freedom, which means I can't do 8 or 9 in here. And I definitely have a 4 and a 5 in here, because if I don't, then I've already overflowed my welcome, and so this is not 4 or 5. Oh, I'm being told I can place 9 here in column 4. No. Take 2. I'm being told I can place 9 here in column 4. Frankly, this one would have been better because it would have resolved tall cats 5, 9. But I suppose beggars can't be choosers and all that. So we know there's an 8 over here in this box now, and so none of these are 8. And indeed, there's an 8 exactly here, for the reason that it's pretty difficult to put an 8 with a 9 in a 4-cell 17 cage. Verify with the killer calculator if you would like. So now there's an 8 exactly here, because you can't put an 8 here or there. So now there's an 8 exactly there. There is a 9 in this 17 cage now, just by Sudoku. And so we can green the 9. Okay, so this is either a 1, 7 or a 2, 6. Ah, so this does have a 1, 2 in it. So there has to be a 1, 2 in here by killer calculator. So that is a 1, 2. It's like when people said that, I was like, no, there's no way. But it turns out, who knew? So these are a 1, 2 pair, and we've resolved the tall cat cell. Because if you just ask where the 1, 2 go in this row, they have to go over here, and so that's the 9. Okay, so now there's a 1 and a 2 in here. Which means that this 17 cage can't be 1, 2, 3, 4, 7 anymore. So this, if this were 1, 2, 3, 4, 7, we'd have to put the 4 and the 7 with the 1 and the 2 down here, and that would be a problem. So instead, this is 1, 2, 3, 5, 6. These are 1, 2, 6, therefore. And so there's no 6 here and no 1 or 2. So these are 3, 5. The way I did it was so much cooler than that, AFK. You've got to admit it was much posher. That 3 looks over there and makes that a 3. Which now, oh, that's right. That doesn't tell me anything. It does make that not a 5. One of these two is a 5. Sure. Interesting if true. Okay, so there's now no 6 in here. Or 1 or 2. So it's 3, 5, 9 or 4, 5, 8. Sure is. 3 in column 4 now is up here in this cage, and hence down here in this cage. But this now has a 9 and a 3, which means this is 1, 3, 4. I suppose I could have noticed that these cells sum to 8 and thought about what I know about sum to 8 things, but I did not. And that is the story. All right, this cannot be 3 by the corner mark I already have. There is sometimes the question of why I make corner marks if I'm never going to look at them, but what can you do? These aren't 3 either. I'll go ahead and update. Gonna be okay, this cell is not a 4 because it definitely sees the 1, 4 pair while we're doing ridiculous eliminations that I enjoy. Okay, there's no 5 in here, so there's a 5. Oh, sorry, the 5 could be there. Never mind. There's a 6 in box 3 somewhere. I mean, it's great for channel engagement when I do that kind of thing, Playmaker. I think that's probably true. Aren't these from 4, 5, 6, 7? I think these are from 4, 5, 6, 7. And I think that gives me a dumb quadruple in the column. There's a smart way to see this. The smart way to see this is to know that there's a hidden 1, 2 pair in column 4. That's the smart way to do this, is to ask where the other 1, 2 goes in this column and remark that it must go here. And therefore, that is a 1, and that is a 2, and that is a 1. Okay. It's like this feels like the kind of deduction that I'm doing just completely ass backwards, which has turned out to be the case. I could have even just asked where the 2 went in the column if I wanted to be fancy about it, but that's a little too fancy for a zeta. Okay, so there's a 2 in here somewhere, along with a 4, 6, or 7, if you're into that kind of thing. Okay, so now there's a 1 over here, and therefore that is the 2, and that's the 1 over there. That seems not to be a 1 anymore. Oh, I know there's not a 4 in this anymore. So that means I know what this is. That means I know this is 1, 2, 3, 5, 6. So these are 1, 5, 6 now. That 4 did work. Okay, so now this is the other ones. It's not the 5, 6 one. So this is 1, 2, 3, 4, 7. Okay, now the 17 cage doesn't have a 7 in it. So this is 2, 6, 9, which makes that a 1. Okay, which is useless because it doesn't resolve that mess. But I guess this is a pair now. Maybe Mark will know what it is. Mark doesn't know. 1, 2, 3, 4. Okay, one of them's a 5, and the other is an 8. And I know the order. Excellent, which gives me the 3 and the 5. Knocks the 8 into here, which makes this a 4, 5, 8. Makes that not an 8. Feels like that's a lot of 4, 5s down here. That is a lot of 4, 5s down here. That's like all the 4, 5s down here. So in particular, these can't be 4. Put a different way, this is just a Zackwing. Whereas 4 in row 7, it's not in this cage and it's not in this cage, so it's here. Is the answer. Okay, so now that seems to have become a 2 and a 3 up here, so that seems to have become a 2 down here. This is a beautiful puzzle, by the way. This is very well put together. These seem to be a 7 and a 9, and I even know the order owing to this 6, 9 pair down here. Don't tell anyone I told you. Let's see. This is a naked single of some sort. It seems to be a 4 now. Okay, so now the 4 is in this cage. So that finally resolves what this cage is. So this cage is... No, this... Ah! No, no! Stop it! No! This cage is this one. I thought I could highlight it somehow. Anyway, 1, 2, 3, 4, 7. So 1, 3, 4, 7. No 1, 3, no 4, no 1, no 2. The 4 is over here, so that's not a 4 either. One of those is a 4. Let's see. This pair is a something something. 2, 3, 4, 5. Let's see. These are a 6, 7. Sure are. It gives me a 4, 6, 7 triple that does absolutely nothing. Wait, is there really a 6 in this? No, there's no 6 in here. Don't listen to me. That's a 4, 7 pair, so that's a 6. It some reason left the 6 there for reasons that no one knows. Okay, so now we therefore know that this is not the one with a 7. So this is the one with a 5, 6. So this is 2, 5, 6 is what's up here. Okay, no 3 down here. There's no 7 left down here because of the 4, 7 up there, apparently. So that is a 3 and a 1 and a 7 and a 3. No 1 over there, so that's a 1. Let's see, that seems not to be a 7 anymore. This is a 5, 6 of some description. Let's see. So yeah, there's a 6 or a 7 down here, but it's impossible to say which one. There's a 2, 5, 6 looking down at this. So this isn't a 5 or a 6. But there's a 5 corner marked in here, and that 5 now looks up because of the 2, 5, 6 triple. So therefore that's a 6 and that's a 5. So no 6s down there. So now this is 4, 5, 7. I suppose. So now these are the other ones. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we got all of that. That's a 2, 6 pair, so these are just a pair as well, which is going to give us this digit if I squint hard enough. Let's see. These are going to be a 3 and a something. 7. Okay, and so now this is the other one. 2, 3, 4, 5, 6, 7, 8. This is a 9. A little bit ho-hum of a digit to turn out to be the last digit in a puzzle that doesn't have 8s and 9s and cages, but we'll take it, I suppose. So now that's an 8. No 6 there. So we've got 4, 7 running up this column. We've got no 6s here. These are from 4, 5, 7. So we need 2 of 4, 5, and 7 in here. This can't be a 4, 5, 7 because this cell sees a 4, 5, 7 triple, which is what Garion also just said. Yeah, this puzzle's incredibly clean. But yeah, this is my favorite kind of Sudoku nonsense, is that this cell actually sees all 3 of these through the mediums of Sudoku and killer cages, so this is just a 6. Okay, and so now we know that this is a cage that has a 6 in it. Okay, so we've got one of these. Oh, I'm dropping frames. Oh, no. Well, it doesn't have an 8 in it. And it can't be this one. So it's got to be this one. And so we're 2, 4, 5, 6. Yeah, sadly, frame dropping, etc. Very tragic. Especially for this lovely puzzle, but you can see a complete solve of this puzzle if you combine my solve and Tristan's solve, possibly. Unless there were glitches during that as well, in which case then I'm not sure. 5, 4, 3, 5, 7, 3, 1, 3, 5, 4, 7, 5, 7, 4. Big heart for that one. excellent puzzle. Great job. They're incredibly smooth. Just all around, very nice. Exactly what I enjoy in a killer puzzle. Alrighty, I will be right back. I need to go pick out another puzzle, but I'll see you all in just a moment. Hello, and welcome back. So, uh, I saw here, oh, let me bump this just a little bit. And I need to bump it up as well. That 99% Sneaky set their first non-Sudoku puzzle that is apparently very humane as far as difficulty goes. It has fishies. Oops, that's not the right thing. I was adjusting the wrong thing. There we go. Let me trim that just a bit. Okay. Thanks, Missing. Hope you have a good Sunday. Sunday, right? Yep, Sunday. I totally know what day it is. So let's see what are the rules here, other than fish. I like fish. I saw this and noped away from it. Well, let's see if we can do it together. So what are the rules? From each clue outside the grid, draw a path which begins in the nearest cell of the grid and then travels orthogonally from cell to cell until arriving at a fish. All empty cells must be used by a path. Paths may not cross themselves, each other, or fish. A number at the beginning of a path indicates how many cells in the grid the path occupies, including the cell with the fish. To avoid confusion among the anglers, no two fishing lines of the same length may touch. This includes both orthogonal and diagonal touching. For each question mark clue, fill each cell along the corresponding path with the digit equal to the length. If the length is a double-digit number, fill the cells with the ones digit of the length. Okay. I agree with AFK that it feels like we wanted to checkerboard this grid to start, and I will explain why in a second. Let me just start, and I'll try and make it as unobtrusive as possible of a checkerboarding. I'll just put some of the fish in water. They probably won't complain too much. Probably the fish that are out of water will complain more. Oops, not that one. Let's see. Okay. Boop, boop. We're almost done. Okay, so the reason why we're doing this, in addition to the fact that surveys demonstrate that people enjoy watching Zeta color things, uh, is that we can say some things about where the fish that a particular fisherman catches. So we've got this. Sadly, I can't actually sort of like color these sorts of things. Oh, we're 2 puzzles behind. Oh, I think Tristan must be asleep. Uh, uh, let's see. Let me grab this one. There we go. So, for example, let's just imagine that this fisherman starts on this square. Okay, so that's a length 1 line. If they cast a length 2 line, then they're going to end up on blue. And so basically, it alternates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. They're always going to end up on a white cell. And so basically, I guess I can pull up my pen tool for this. This will probably be a good way to do it. This is always ending up... I don't know why I thought that was going to put a W on the screen when I pressed 7, but in my head I was 100% sure of it. This is going to end up in a white cell because it's going to have the same parity as this. And we can do the same thing here. Like this one's going to end up on a blue cell. And we can continue doing that as we go along. So in particular, that tells me like what fish are actually possible for various sorts of things. Okay, so we probably have some low-hanging fruit, like this 2, for example, I think just has to catch this fish. I don't think there's any other options for this fishing line. So I think this fishing line is done. Yeah, I mean, that's definitely, yeah, I'm not going to write B for blue. That would be silly. We all know that B is black. What? Begins in the nearest cell of the grid and then travels orthogonally from cell to cell. How many cells in the grid the path occupies? I think I did it right. But 7 doesn't go to blue. 1, 2, 3, 4, 5, 6, 7. Looks like it goes to blue. Odd means same, even means opposite. I'll go ahead and circle these just so that we know that it is done in every possible way. Should I don't know. Sorry, I should definitely not remove that. Should I remove the circles? No, I like the circles. Okay, I think maybe I should remove the 2s. I don't know. Maybe I should not remove the 2s. Yeah, we do have to make sure the 6s don't touch. Which is going to be hard, I guess, if the 6 goes up. Right, so people want me to label these things. So, like, this is blue. Oops. This is white. Oops, sorry, wrong tool. That's white. Okay. Okay, so this is going for a blue fish. No, sorry, I did that backwards. Because these are even. So, in fact, this is going for a white fish. This is going for a blue fish. Yes, I did do that backsies ways. Uh, oh, right. They can't even touch diagonally. Okay, so yeah, so this line that starts here, I guess I should just label all the starts of the lines with a circle. That's probably a good way to do it. Maybe I should label all the starts of the lines with an X. I don't know. Uh, this can't even go down there, and it can't go there either, right? Is the thing people are claiming, because the lines aren't allowed to touch even diagonally. And so this has to go this way, and it can't take a fish yet, so it has to go down. It can't go that way. It can't take a fish yet, so it has to go down. Also, if we want to think about this fish, I'm going to X the fish. We want to think about this fish. It's got to connect to something, and it can't connect to the 6. So it's going to have to come down here. These can't connect again. This is going to have to come down like that. This still needs to get a fisherman, so this still needs to come down. We'll Fominoize this just for sanity. This may be easier. This is really like a Fomino puzzle, except that the ominoes all touch the border and include a fish, and ominoes of the same size can't touch diagonally either. The row 1, column 4 fish. Yeah, we can sort of separate the fish, and we can, of course, separate the circles. Yeah, this is much better. So yeah, so this is, instead of X's, we can do that. And so we can do that, which lets us do that, which lets us do this. Okay, I think this is much better. Now this can connect here. It will be 6. And that's okay. We certainly know the fish doesn't connect to a fish. We can draw in some more of these, like that one, for example, we know goes there. We know it doesn't take that fish. This one we know extends. This one we know extends. I guess maybe I have to be a little careful with the black borders, depending on exactly how I'm interpreting this. Because, like, this can still end up being a 6 omino like that. So, like, I can interpret, maybe I should have left that, I'll leave this one as that, maybe. Row 3, column 6. It needs to connect downward to one of these two, that's for sure. But I don't see the rest of the claim. Oh, the row 3 clue. Sorry, yeah, this is looking for a blue fish. It's certainly this blue fish. Right. So yeah. So okay. So this is the only blue fish that's accessible, and the point is, if this were to steer here, now it's going to do that, and now these cells don't have anything to go with them. Right. So that makes a lot of sense. So actually, we can sort of fill in this omino with our sixes. Okay. It doesn't like me doing that. I guess I can turn air checker off. Okay, there we go. So now I can, now I can fill in sixes. And put an X over this fish. Okay, so now this one goes forward, and it can't connect to the 5, so it goes forward. We know these never connect. We know this doesn't go down at the very least. We know something goes through here, so we can fill in that at the very least, because something has to connect to something. This has to connect down. Technically, here is one of those instances where what I should actually have here is an X. I'm putting an X because this could still be the fish that the 11 takes. I think. It actually can't be the fish that the 11 takes, but I haven't gone through and done my letters yet. Okay, but this definitely can't connect there. So this comes down here. This comes over here. The 5 can't connect to the 13. So the 5 continues, and now the 5 has one more line in which to catch a fish, so it catches that fish, and then we do that. Certainly know these aren't in the same fishomino. Oh yeah, that's true. We can certainly mark that this is a corner. And it certainly doesn't connect to that. So it comes up. It doesn't join this, which means that this extends and this extends. We can do that. It doesn't join this either. So this extends, this extends, this extends. Oops, that's not the thing I wanted to do. So this extends, and now we get our usual sort of loop puzzle extension chasing. Like that. And in fact, this comes up like this. We get to separate that, and now this comes up. Rest well, playmakers. See you soon. Okay, and now we count. 1, 2, 3, 4, 5, 6. Okay, so it can't take that. In fact, it can't take it at all. So certainly it goes this way. There's actually a black border here if you look at the color, because this needs a white fish, not a blue fish. And so now it needs its fish, and so we're at 1, 2, 3, 4, 5, 6. It's only got one more cell it can go, and so, oops. So it takes this fish, and then we go, and then we X the fish. And we extend this up, and then we extend these two up, and then we extend this one up, and then we separate this, extend this up, and all of that is good. We might have to start counting these 16s and 17s and stuff. I don't know. We might actually want to label these. So this is looking for a blue. This is looking for a white. This is looking for a blue. This is looking for a blue. This is looking, oops, for a white. This is looking for a blue. This is looking for a blue. Yeah, this is looking for a white. And then the rest I don't know. Okay. I can certainly separate these two, which I have not done. This is looking for a blue, so I don't know. I can at least draw a little X there, but that's not so helpful. This is looking for a blue. I can also draw a little X there, so we can sort of draw the net going back out of there. Like that. We certainly, again, can sort of X these off. And so that goes that way, that goes that way. This 8 can't connect up or down because it's an 8, so it extends one forward. Let's see. I'm glad I don't have to hit a live button every once in a while in order to stay alive. At least I hope not, because I haven't hit one in a while. Okay. I think I got the 8 goes left business. Oh, let's see. I can fill in my 5s now. And my 7s. Row 10, column 13. Oh, right. This fish could go down. You're right. Sorry, I don't know. Yeah, I made a boo-boo there. Good catch. Likewise with this. If the 11 connects here, is it a problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, the 11 definitely isn't connecting to that fish. 3, 4, 5, 6, 7. Yeah, it's not within 4 of any blue fish if I make this connection, is I think what people are saying. Oh, does it affect this logic? I think, yeah, I think you're right. I think I now have to undo that. But yes, I agree. This has to go this way. And we know these are separate. We know this. In fact, we know this just doesn't take this fish because this fish is the wrong color. So it continues over here. This continues over here. We know these paths are all different. This one continues. This one continues. This one continues. Okay, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can draw at least a little X there. Does it break this whole area if I connect this down here, and do I want to try that? No, I don't think it does. Oh, the 11 can't go there? Okay, the 13 needs to get to a blue fish that is 3 away from here. And so looking at blue fish that are within 3, I think I agree with AFK that's only this one. So I think this has to do that. So this has to come down at least. 3, 4, 5, 6, 7, 8, 9, 10, 11 is certainly an option, and I don't think there are any other options, weirdly enough. So you've been caught, you've been caught. I think that's right. This has descended a bit into reachability arguments. Okay. 8, 9, 10, 11, 12. Okay, so we've got 5 more moves to make with this this business. Two, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, yes, this is a corner. Agree. That goes that way. Oh, we have 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah, we've got 13. Okay, so we've got 4 more. This is definitely a great first pencil puzzle. This is 99% sneaky as first attempt at a nun Sudoku puzzle, they said. I think technically I'm only supposed to do it for the question mark clues. I was just filling it in for the others for my personal sanity and for scanning purposes. Oh yeah, maybe the 4 clue is now done because it indeed needs to go here, right? Yeah, there's no way it can go somewhere else. Okay, so something goes through this corridor. Obviously, this doesn't connect to the fish in the middle. That's a good spot from Josh, is that we actually know that regardless of what happens, this line is going to go through here. So we can draw in a line here because we have to go through the fish to escape. And so this is actually connected to that. So so therefore it actually has to connect to this as well because this is going to connect to it one way or the other. And so therefore this actually connects like that, which is a bizarre eventuality to have happen. But what can you do? And now this is a corner, and so in so doing, that finishes the 6. Like that. So we can fill in our little 6. We can extend the line backwards from this. In fact, extend it twice if you like. We can extend the line backwards from this, extend the line backwards from this. We can do the 2 out of 3 loop trick to draw a line here. Because if we didn't draw this line, it would go straight up and down and it would connect the 2 fish, and we're not supposed to do that. Okay, and we do have to remember this diagonal rule, which is very weird. I think this is the 7 clue Davita's asking about which blue fish it's going to get, and it's got to be this blue fish because there are no more blue fish available. I think I do agree with that, and so it's got to do this exactly, right? I think so. Uh, uh, there's no other blue fish in a 500-mile radius. That seems correct. Okay, so this is a corner now. Oh, this I've never actually extended, but I could extend by 1. Oh, I suppose this is a corner now too, actually, huh? Because this definitely doesn't go that way because it went this way. And so we can do that. And we know these two are different. Yeah, this is quite nice. I enjoy this. Okay, so this is looking for a white fish, so it could be that one. This is looking for any colored fish, so it could be that one. So I can't really say anything about those right away. Row 2, column 12. Yeah, it can't go that way, so it has to go that way, because otherwise it would connect an entrance to an entrance. Oh, if these connect, the fish is too far away, says Gary. And 1, 2, 3, 4, 5, 6. Yeah, then the fish would have to be within 2, and it's nowhere close. So that's not actually part of the 8 line. The 8 can't take this fish, and so actually this fish therefore just goes that way now. And so this is just a length 2 fish, is what has been forced out of that. 2 length 4. Okay, this is a corner now, so we can do that. This is a corner now, so we can do that. This is a corner now, so we can do that. The only... Oh, sorry, no, this is looking for a blue fish, not a white fish. So this can't go down, because if it did, it would get the white fish. It's not supposed to do that, which makes this a corner itself. In a weird sort of way. So this fish is done. And that's 7. This extends back this way. So this is now trying for that fish, right? 1, 2, 3, 4, 5, 6, 7, 8, something like that. but it can't do that because it would leave this cell isolated. Uh, so it's got to extend this way, I think, is the upshot of that. As if it doesn't, we end up with that shape that leaves this cell isolated. We can't isolate to this cell. Yeah, I guess the thing to say is I can't do this, is the way to say it. Because if I do this, I block the 8 from getting there in 8 steps. So I always do that, is a less begrudging way for me to say it. These certainly don't connect because of the 8. In fact, the 8 now is done. 1, 2, 3, 4, 5, 6, 7, 8. We can fill it in like that. We can connect this up. We can mark this fish as got, by the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, yeah, probably those connect, but I don't think we can prove it yet. Okay, this is a corner. This is a corner. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so these can't connect or it'll be too big. So it's got to go this way and that way. And then it's done. And now this is a corner and we get that. So there's a 6. I feel like the rule about the things touching even diagonally has not really come up. But possibly that is just because I'm not counting goodly. Okay, I do know this certainly doesn't go this way, at least. Yeah, the very first set of 6s used the rule, and then we've not used it since, I think. 'We couldn't have done something like this without that rule, Garion? It looks to me like that might have been an okay way to start if we didn't have that rule. But I don't think we've used it since then. 12. I'm confused about how we know about the 12 not being able to take anything else. Is it like a connectedness issue? Yeah, that's what I was afraid of, but that feels difficult to articulate, doesn't it? True. This always goes down. That is a very good spot from AFK. Because if it doesn't, we end up connecting a loop to a loop. We don't want to connect a loop to a loop. Uh, so basically, I guess the way that I would try and say this is that all of these connect to fish This is just a giant wall of stuff that all connects to fish. And so if I do pass this up, then I have to connect this fish over to this 12 because the fish can't change orders. And that doesn't work. I don't love it, but I believe it. Basically, because of this wall of fish that exists over here, and I know this is fish because it connects either to that fish or that fish. Because of the wall of fish, this fish needs to connect to something on the basically on the bottom. And so if it isn't this, it's going to be that one, I think. Anyway, I think these two connect, even if it's slightly more reachability oriented than I like in my deductions. I am a well-known reachability argument hater. Let's see. So we've got that. We can use AFK's argument from before to say that this connects that way, because if it doesn't, then we would bounce and we would connect those over there in a way that would be bad. Yeah, that's basically how I argued it, Zombie Hunter, was I argued that it was really about this fish and his destiny, although I guess this fish would probably prefer a different destiny, all things considered, given the theming of the puzzle, but what can you do? But this fish now has to connect here. The row 5 question mark can't go up. Ah, right. It would trap this circle in a funny way. Yeah, that is a good spot to Gary. And yeah, if this circle goes up, then if you look at what it does, it then bounces around here, and now this circle has nowhere to go. So, in fact, this goes here. And in fact, actually, the prohibition is actually just on these. Well, I guess, yeah, this now can't connect down. So we can move it over there. But basically, this circle is definitely connecting to this, regardless of whether it does it directly or indirectly, and so therefore it's blocked off from this area, so we can extend that like that. Okay, now this can't connect here because of similar reasons, right? Oh, maybe not. Sorry, maybe that's not true. Maybe I can connect these. That's annoying. I think I can. Yeah, we've got this sort of connectedness thing where, like, now this needs to take this fish because they're along a border and nothing else can go along that. Nothing else can appear between them to separate them. So we actually know that these connect, I think. Oh, unless these connect. Yeah, maybe that's faintly plausible. Never mind. David says this can't, or sorry, Garian says this can't go up. because if so, I create this problem again where I've got to connect this, and it can only connect to two circles. So we can mark that off. We still know that these don't join by our previous argument. So that goes over there. I think if this goes up, we end up screwy. Because if this goes up, you can ask where do the two ends of this eventually connect, and the answer can only be these two circles. This end, I guess, here's the way to say it. Yeah, here's maybe an easier point. This can't go right, because if it does... Oh no, sorry. I had it in my head and then it went away. I feel like I don't think this can go up, because then I think I get to make the same argument. Because if this goes up, then the two ends of this have nowhere they can connect to except to the circles, right? I think that's true. And so this again doesn't go up, it continues. This we know slides this way because of the aforementioned note. These can't connect for the same reason. If these two connect, then eventually it connects to both circles. So this extends. Right. The 17 is in here somewhere, right? The 17 sort of can't avoid being connected to this. And so even if it goes this way, the long way around, it's still not at 17 yet, so it has to go left. Agree. Which means it's not getting this fish anymore. Which means that, in fact, this is getting this fish, and we have a little 4-size fish here. Which I think is a thing we used to believe was not possible, but we apparently gave up that belief. So this continues over here. Okay, I can't go up and down with this, because that will connect the circle back, so that has to go that way. And I can't connect this way with this, or it'll create the same problem, so I get my usual, like, I think this is called bouncing or something. In typical loopy puzzle fashion. And we now probably have to be worried about lengths of things. Would be 11 if it went straight forward. That doesn't seem to break anything. Yeah, the 17 definitely has to connect to this fish. I agree. Uh, but I don't think that tells me anything, does it? I think I know that these are all true borders. Oh, there is an 11. Sorry, there is an 11. Isabella is correct. I looked at the 12. I didn't look over here. This is an 11. So this does need to bend at least a little bit. Uh, so this could be a 13, for example. Or a 15, but not a 17, presumably. Maybe it could even be a 17, actually. Hmm. Mystery. Okay, yeah, this is currently 15 cells. So it gets to take one little skirmish. And so it either takes this one or it could bend down at one of those points. Oh, right. That 15 included a detour that may not happen, right? So maybe it does two detours. Uh, I think if this goes up, I think it's impossible. So I think if this goes up, I think I don't have room to allow this 17 to get to 17 because it would have to do it here, but then I make the 11 and 11. Or sorry, I make the thing that's known not to be an 11 and 11, right? I don't think that works. I feel like there's probably a nicer way to say that argument than the way I said it. Uh, okay. So the 17 needs two detours. This is Isabella's argument. It can't have both of these detours because if it does, this is a nicer way that gets at the same point I was seeing. Isabella points out if this tries to take both of these detours to get to 17, in other words, if it tries to avoid this, then that forces this sort of double pancake version where this is an 11. So we can't do that. So this always takes that. That is a much nicer way to see that. Okay. Uh, Oftentimes in pencil puzzles, it's a matter of, okay, I see a way to see this, but the way I see to see it, I guess this happens equally in Sudoku. I see a way to see this, but I don't like the way I'm seeing it, so I'm going to look for something else. Is a very common refrain for me. Okay, these certainly aren't part of the same omino, or that omino would have too many things in it. Uh, okay. Okay, right. And now uh, Right. This has to take one of these two detours. And so if this is the detour it takes, then it forces this to not be able to take any detours up here. And it can't get its additional detour. I'm trying to find the way to say this that involves like drawing an X somewhere, but I'm not quite sure. In any event, it still is true that if this connects up, we break the world, I think. Because then my 17 runs across, and then bumps down here, and then this bumps down here. There's probably a nice way to say this that involves something like, oh, I just can't connect these two because if I do, then it doesn't work. I mean, that's definitely true, right? Maybe if I say these words enough, it'll connect. Because if I do connect these two, I break both detours that this can take to get its extra 2 cells. If these don't connect, that also creates a problem, because if these don't connect, then I'm obligated to do this, and that certainly creates a disaster. So we can connect those two. If these don't connect, Yeah, I feel yeah, I thought when I started putting X's and drawing lines, I thought I was going to get the elegant version, but I did not end up with the elegant version as of yet. Uh oh, Zombie Hunter says it is elegant. Uh am I supposed to say something about like this connection? Uh Well, I think I already said this detour breaks the puzzle, right? That was what we said before we got through these points, is that this detour breaks the puzzle. It just breaks the puzzle in a way that doesn't feel doesn't feel intended. Uh but at the very least, with all that we've drawn in now, it's very clear what happens if I do take this detour. Uh uh Yeah, I mean, it just breaks the 11 touching an 11 thing. But yeah, we said that before. I just this doesn't feel elegant. This feels a little bit messy, but I can't quite do it in a way that does it. But anyway, the point is that this goes through here, and now the 17 has its 17, uh, and so we can draw in that. Draw in that. Like that. And now this needs its detour there. Oh, that sounds good, Anik. I like that way of thinking about it, is to sort of think about the two detours collectively rather than individually, and then see that what's happening is that if you place them collectively, you're getting a an issue. That sounds good to me. Uh, uh, Great first pencil puzzle, by the way, as these things go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so this is a 2. 8, 9, 10, 11, 12, 13. Let's see, this is 11. This is 12. This is 13. Oh, it's the ones. Sorry, in my brain I remembered it was the ones digit. Oops. So now I have to count this again, don't I? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, funnily enough, it is 2. No, I just thought it was the ones digit. I thought it was the tens digit I was writing. I thought it asked for the first digit. So I counted, and then I just misremembered what the rule was. So this is a 12. So that's what I thought, Nell, but someone in chat said they tried it and you actually have to fill it in all of them or it doesn't work. So I'm going to fill it in all of them, but if it doesn't work, then I can delete the others. Okay, so it might turn out I have to delete the others, or it might turn out that I erroneously wrote the digit of one of these. I started filling them out just as a Fomino exercise for myself and to mark stuff. But yeah, I guess I probably have to do it the other way. But anyway, quite enjoyable. I look forward to seeing more pencil puzzles from you, Sneaky, as the pencil puzzles slowly take over the world. But I'm going to take a quick break and come back, and we can do some 6x6s. So see you all in just a moment. Welcome back. We have a Dorlier puzzle, which is, I think, a sequel to another Dorlier puzzle that I quite enjoyed. So let's have a look. So we have I could put on row column labels too. That'll make my life easier. Normal Sudoku rules. Box borders divide the line into 2 segments. The product of the digits on one segment equals the sum of the digits on the other. Okay, so these digits have the same sum and product. Oh yeah, I can do that. So these have to be 1, 2, 3, I believe. Let's carefully prove that they have to be 1, 2, 3. So the maximum sum is 15. So if we think about it, oh hey Dr. Roach, welcome. Glad you're enjoying the blueprints. Let's see, we're trying to argue that this has to be 1, 2, 3, which I'm almost positive that it does. Yeah, I guess the point is it has to have a 1 in it. Because if it doesn't have a 1 in it, then its product is a minimum 2, 3, 4, which is 24, and you can't get to a sum of 24. So there has to be a 1. And now the maximum sum is 12. And so now you need a now you need a 2, because if you don't have a 2, then you're at minimum 12 for the product. But the only way to do 12 for the product as a sum would be 1, 5, 6, which doesn't work. So you need a 2. And so now you know the last digit has to be 3, because 2 times the last digit is equal to the last digit plus itself. So now you get that it has to be 1, 2, 3. I feel like there's probably a nicer way to do it, but we'll make do with that. That's the intuition, Garion, but I feel like that's not quite an argument. Okay. This has to be the sum, not the product. So we'll do sum. Let's see. I'm trying to think of colors for sum and product. Anyway, it's not 4, 5, because you're not doing. You're not doing. Yeah. Yeah, you certainly could prove it with calculus if you wanted. Yeah, 9 won't factor and 11 won't factor either. So it's got to be 4, 6, making that a 5, and making these 2, 5 in order to work. Let's see. So we've got 1, 3, 4, 6 left. This had better be the product side, right? If this is the product side, the minimum is way, 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 way too big. So this is the product side. So it can't have a 1 in it, because the minimum sum of these is well, anyway, the minimum sum of these is at least 10. Also, I need to have a 3 in here, because otherwise the product is 24, and that's too big. 18 is just doable. These don't have a 3 in them, but they do have a 1 in them, for what it's worth. 1 plus 4 and 1 plus 6 are both prime. So if this is the sum side, then this side is a 1. If this is the product side, then this could still be 2, 3, I suppose. This would be a fun idea for a pick 6 digits out of 9 puzzle. I agree with that. Okay, so if this is 3, 4, then these two add to 9. And so they're 4, 5, or 3, 6. It looks like that's okay. Yeah, mean many is the, like, choose 6 of 9 kind of puzzle. Garion is claiming I can't make these two cells add to 18. So yeah, so the if I make this 3, 4, the problem is that these are either 4, 5 or 3, 6. So we have to take those cases in turn. But the argument is in both cases it can't be a product because the product would be at least 18 in one case, 20 in the other. And I can't make these sum to 18 or 20. So in fact, it would have to be a sum, and the sum would be 9. And then I'd have to make these a product of 9, which is, as remarked, we cannot do. So we can't make this 3 times 4. It's got to be 3 times 6, which makes this 1, 2. Now I can't make this 1 times 2, so it has to be 1 plus 2, which makes this 3 times 1. And so, oh, right, and AFK's even doing some Sudoku for me. Sounds good. 3, 4, 5, 6. That's not a 3. Oh, I've turned off conflict checker, apparently. Let's put conflict checker back on. So that is not a 1 or a 3 or a 2 or a 1 or a 5. Okay, these are 4, 5, 6. The ones look up column 4. Very good. So that's not a, so that's a 3, a 2, and a 1, a 5, and a 2. 3 and 5. Oh, this is a 3, 6 pair. So that's a 1, 4 pair. So this can't be a sum because I can't do a product of 5. So this is a product. And so that means that, doesn't that make this also 1, 4? No, sorry, that makes this 1, 3, right? This is a product. Sorry. 1 times 4. Oh, wait, sorry. What am I? Sorry, someone said 4 by 4, and then my brain went to, okay, I can't use a 5. Sorry. 1 times 5 is a valid product for 5. I don't think I know what Sudoku-vania is. But I'm not. I've been doing Let's Plays. They've been popular. I've been enjoying doing them a lot. So it's not outside the realm of reason that I could do a thing for. Oh, it's similar to the Caterpillar Doku. Yeah, 1 times 4 would make this 1 times 4, which doesn't work, but I don't know why. Other than that it would obviously not work. Let's see. That is a 6. Well, my point is that would be a deadly pattern. So, oh, right, sorry. You can't do 1 times 4 equals 1 times 4. Right. That's not how the puzzle works. Although now I kind of like the version where the lines have something out of the sum and product is equal. I think this is just some variation of this. I don't think this rule exactly, but some variation of this I think is deserving of a 9 by 9. So yeah, so if this is 1 times 4, this would be 1 plus 3. That doesn't work. So it's 1 plus 4 is 1 times 5, which would make that the 1 and that the 5. 4, 1, 2, 3, 1, 3. I wish this step hadn't been quite as messy as it was. It It did, at least in terms of setting. It had a hint earlier because it earlier came up that you couldn't do 9 as a product. Uh, but yeah, I think this has a lot of potential, I think. Let's see. So that's a 6. Okay, so this is the 4 and that's the 6. That's the 5 and the 4 and the 5. 3, 5, 4, 6, 3, 6, 4. That's a 2, 4, and 2. But very nice. I like that, and I like it being ambiguous which side is which. I think this is a fun sort of ambiguity, and it plays nicely in the space. Like that, we've seen a lot of puzzles that involve multiplication, and the problem with multiplication in Sudoku is that multiplication of the digits 1 through 9 or 1 through 6 just isn't very interesting by itself, because, like, for example, if there's a 5 in it, there's a 5 in it. There's just no way to do it. If there's a 7 in it, there's a 7 in it. It's not very interesting. But when you combine the product with the sum, then suddenly you get a lot of interesting interplay between them, and I think that's very compelling and interesting. And I would like to see more stuff in this vague space, whatever that means. Alrighty, let's find another one. Let's see. See, but I don't think you want 5s in play. Like, I think 5s are just poison for, like, 5, 7s, I think, are just poison, basically. Uh, uh, okay, let's see. Oh, we have a Menomino-themed J. Dyer puzzle. So normal Fomino rules apply. So we'll turn the grid on. The number in a cell with 1 or more arrows indicates the distance to the first Fomino seen in each of the indicated directions. The first cell after the arrow is at a distance of 1. Okay, so this must be a 2, right? You can't ever have a monomino at a distance of 1. Oh, I guess you can for the diagonal ones, but not for this one. This has to be a 2, with that being a 1 and that being a 1. Hey, Juggler, how are you doing? I haven't gotten around to your next Sudoku hunt yet, but I'm looking forward to it because I know it is in there. I have it in my bucket, I think. Let's see. This is at most 3, so this is either a 2 or a 3. Because it sees 1 3 away, but might also see 1 2 away. Let's see. This one sees 1 at most 4 away. These two can't be equal to each other because it can't be a 1 because that would be a monomino pointing at a monomino, which would break Fomino. These two need to be separated because... oh, sorry, this one could be a 1. Right, sorry, that one could absolutely be a 1. But these two are different. And this one's at least 2. So this one's at least 3. Indeed. Let's see. Juggler believes this can't be 4. Yeah, if this is 4, it would put a monomino next to a monomino. Likewise, this one... can't be 3 for the same reason. That one can't be 5. Okay, good. Oh, these two can't be equal is also a good point from Ron, because if they were equal, they would put two monominos next to each other. I do know one of these two is a monomino, for what it's worth. So I know these aren't monominos, for whatever that is worth. Okay, so this can't be as large as 3, even. So this is only a 1 or a 2. I think that means this can't be a 1, right? Because if this was a 1, that would be a 1, which would break this doohickey. So that can't be a 1. So it's a 2 or a 3. Hey, Isaiah. Most of a stream, actually. This can't be a 2 because it would block this one. Because the... No, not quite. Garion has the point. This can't be a 1. Because if this is a 1, now that's a 1, and now this is broken. So this is at least 2, but it's not 2 either. It is, in fact, at least 3, but it's not 3 either. Oh, sorry, maybe it is 3. Sorry, it could be 3. It's 3 or 4. And so that means this isn't a 3, it's a 2, and that's a 3. Which makes that a 1. Which makes this a 4. Which makes that a 4 for sure. Makes that a 3 for sure. Now this is a 3, right? And this is a... Oh, maybe this is a... I'm not sure about this yet. This might still be a 1, if that's also a 1. Certainly draw in that, at least. Oh, and it certainly doesn't go to here either, because this digit can only be a 1 or a 2. This can't be 2 because it would break this cell. So this is a 4. Which now makes this a 4. Because we've just said that. I should have been rainbow coloring the cells that weren't monominos all along, but I resisted, but it was all for naught. Which makes this a 1. Let's see, that's always going to be a 4, because the 4 has to get out somehow. We know these are borders. Oh, this just can't be a 2 anymore. It's going to be a 1 pointing at a 1, because that became a 3 at some point. It is true. They would not be very monotonous. Uh, oh, right. This has become a 1 as well because of that. Right. So that's a 3. Uh, this is 2 or 3. It's the same 2 or 3 as that one. Yeah, that one is 4 now. So that's 4. This cell's always part of the 4 because if it isn't, the 4 touches another 4 in a way that is not appropriate. So that finishes the 4. That's a bit of a weird spot, but gettable. Okay, which makes this part of the 3. It's gross, so it's at least 2. Ah, right. 3 would be too big. 3 would put a 1 next to a 1. So this is, in fact, 2. This is now just a 3. Oh, it could be 5, can't it? Do I know it's not 5? It's not 3. Yeah, I think this can be a 5. Good catch, good catch. This can only be a 2, right? This thing is bigger than size 1, but it's smaller than size 2 because of the force touching. Thank you, Ed. I was trying to prove it wasn't 2 because I thought that would be the less pretty option, but it turns out it was 2. So those are 4s. So that's a 2. That's a 3. So that's a 4. That's, in fact, also a 4, just so we could do that. The world always needs more Fomino's. So now we need, if this is a 2, it breaks, because then we would have that this would be at least 2, but of course it would be bigger than that, but then it would be 3 touching 3. So in fact, this is 5. There we go, with an appropriately monotone grid. Voila. Very nice. Let's see. We have Mini House by Inferio up next. 3 and 2 was not possible because of the 3 touching the 3 issue. I have tried to set a 10-line Fomino before. You do run into the issue that you can have 10, 10, 10, 10, 10 along a thing. 3 above and 2 below, then we'd be saying there was a 1 where we couldn't put a 1. All right, let's see. We've got normal 6x6 rules, normal run bond, normal killer cages. Okay, so this is all normal. Okay, so this is a 1-2 pair. This is a 1-3 pair. Inferio is a rock star. I agree. So this has a 5 on it, and it's from 456 because you need an odd digit of some description to live on this thing. We also need one of these two to be a 5, funnily enough. Uh, let's see. Okay. This digit sees every cell in the Renbon except the 1 or 2. So this digit can be a 1 or 2 or a 6 because this is a length 5 Renbon. So the only digits that are left off of it are 1 and 6 potentially. But of course, this can't be a 1 because of the 8 cage. So this is always a 2-6 in the weirdest possible way. I'm trying to decide if I know something about how the 2s are distributed, but I don't think I do. I do know that this isn't 6 and 1, but that's not interesting. I don't believe. Okay, so there's a 2 or a 6 in this 7 cage. Yeah, Garian says that backwards of the way I was going to. So this is 2-5 or 1-6. That one's not a 5. So that one's not a 2. Yeah, these cells see a 1-2 pair for what it's worth. So these are from 3, 4, 5, 6, and this one, of course, isn't 6. It's possibly gratuitous. Almost assuredly extremely gratuitous. Okay, so I guess what's the digit that goes with this 2 or the 6? It's a 5 or a 1. So this is always a 1 or a 5, because you've got to put that digit down here somewhere. Oh, right. We can repeat the geometry from before, Ambrose points out. This Renbon, or this digit sees every digit on this Renbon except for this one. So this digit could be a 1, a 6, or that digit. Well, 3 isn't any of those things, so this can't be a 3, so that's a 1. Okay, so that's a 1, not a 1, so that's not a 6, so that's a 1 or a 2. This is now the only spot for 1 on the Renbon, for what it is worth. These are from 2, 4, 6, for what it is worth. Right. This Renbon has a 5 on it somewhere, and all 3 of those spots for the 5 see this cell. So that's a 6 and a 1 and a 2. Makes that a 1, which gives me the 2 and the 1 over there. Means that one of these 2 is a 2. I guess this Renbon needs a 2, and it's definitely not there, right? So the 2 has to go there. Because this cell sees a 2-6 pair. So that's not... Oh, sorry. No, this Renbon already has a 2. Never mind. Sorry. Never mind me. Now, this Renbon does need a 2, and it really doesn't have one yet. So that's 2. So these are a 4 or 5 pair, just because of Renbon doing Renbon things. That's a 3. So that's not a 3. And so now this Renbon needs a 3, and so it's there. By Sudoku. There's already a 6. So this is a 4 or a 5. This needs a 4 on it, though, because this Renbon needs an even digit. And that even digit is neither 2 nor 6. So therefore that's a 5 and that's a 4. This is 3, 4, in fact, is all it can be. So that is a 4 and a 3. I see that Garian did that in a smarter way. So that is a 6. This is a 4 or a 6, whichever one it happens to be. That's a 4 just by good old Sudoku. That's a 5 by similar logic. It's a 6, making that a 4 and a 5 and a 6. Let's see. There needs to be a 2 in this row, and a 5 in this row, and a 3 in this column, and a 1 in this box. And a 1 in this column, and a 6 and a 5, making that a 4 and a 5, making that, not that, that a 2, a 4, and a 3. Da-da-da-da, we did it! Very nice setting, by the way, too, Amphirio on that one. Okay, let's do one more. By the way, I try and mention this often, but I accept submissions for a couple things, and people who set often ask. I don't accept stream submissions, but I accept submissions for 6x6s for the end of stream, which I guess you could call a stream submission. And I accept submissions for my Invitation to Puzzles series. So that is to say my sort of intro to Sudoku and other puzzle variants. So you can submit either of those on Discord. I'm happy to have them. I don't promise I'll use them, but I'm happy to have them. And I will likely use them. Also, if you want to include any suggestions about games for me to play or whatnot, you can suggest those as well as I continue the Let's Play adventure. Because admittedly, I have been enjoying those a lot. And at least based on comments, people seem to be enjoying them as well. And I will spoil, I think Lorelei and the Laser Eyes, which is the next Let's Play that is starting, I think that's the best one I have done so far. Okay, so we have Between Lines and Thermos. It's funny because Between Lines are just bad thermos. So we've got sort of like thermos and bad thermos, the puzzle. Okay, so these are not 1 or 6. So let's mark these as not being 1 or 6. This is also famously not 1, 6. So if I ask myself where 1 and 6 go in column 3, I get them as a pair. Namely, that's a 1 and that's a 6. Let's bright yellow those. We will mark these as not being 1, 6. This is not 1 or 6 because you can't put 6 in the bulb of a thermo. So that's a 6. That's not a 1 or a 6 because you can't put 1 there. And so now these are a 1, 6 pair, and I know the order because of the degenerate thermo reasons. That can't be a 1 or a 6, so now that's a 1. These aren't 1 or 6, so these are 1 and 6, and I can't repeat the 1. So that is a soups. That's a 6, and that's a 1. Okay, this now is not 1 or 6. This isn't 1 or 6. This isn't 1 or 6. This is not 1 or 6 because it's the tip. The 1's actually placed right here, actually, for lots of reasons, which places the 1 up here. And so that's the 6. And that's the 6 over here. Got a lot of 1, 6 between lines. I don't know, Malrog. That's a lot of 1, 6 between lines. Okay, this one though has got to be a 2, right? Oh, sorry. I guess it could be a 3. Oh no, it could even be a 4. Sorry, it could even be a 4 because this could be 5, 5. These are from 3, 4, 5 though. That's not a 3. Okay. This is at least a 2, so this is at least a 3. Okay, this can't be a 5, so this is a 2 or a 4, making this a 3, 4, or 5. One of these two is a 3, I suppose. If that one's the one that's the 3, then that's a 2, and that would be great. Are we making an XYZ wing or something weird? Let's see. Okay, this column, I probably should ask about digits in this column since there's lots of them. Okay, there's a 2, 4, 5. Good news, I don't think it's an XYZ wing. Uh, uh, let's see. Column 1 has a 3, I have been informed, which removes 3 as an option from here. Very wise. Yeah, one of these two is a 3, I suppose. It's a different way of saying similar things. If this is a 4, then this is a 5, 5, which feels like it should break, but I don't know that it does. That's a good point. Where does this digit go in this box? This digit definitely goes here, so that's never a 5. At the very least. So that's a 2 or a 4. Not 100% sure if it's that 2, 4 or that 2, 4 or not, or if they're all the same 2, 4 or all different 2, 4s. Hard to say. Uh, oh, wow. Yeah, there's a weird interaction here. Between what happens if this is a 4. Maybe this is some sort of wing. If this is a 4, it makes this a 4 and that a 5, so it makes that a 2. And so now this is a 3 and that's a 4 and the thermo is backwards. I feel like there probably is a way to phrase this that's like an XYZ wing or something, where we use the thermo as part of the thermo or the between line or something as part of the piece, but I don't see it. Uh, uh, yeah, it's tantalizingly close to being a like, oh, this is just this classic Sudoku technique that has been put into here, but I can't quite make it happen. Anyway, this being 4 still doesn't work, even if I can't give you a good reason why it doesn't work. So I will go with it. So that is a 2, which makes that a 2. Makes one of these a 2, and it's not that one, so it's that one. Right, that 4, 5 goes there. Yeah, okay, so here's a better point from AFK that I think we could have seen. Maybe not. Maybe we can only see it now. But this can't be a 4, 5, 6 triple because that makes this a 1, 2, 3 and this a 4, 5, 6. So this needs to be a 2 in order for that to possibly work. This is a 4, 5. Let's see. Yeah, maybe it doesn't quite do the same thing. But it sounded great. I mean, I liked it a lot as a deduction. 3 in row 3. I don't think oh, I do know. Right. This can't be a 3 anymore because that can't be a 2 anymore. So yeah, so 3 in row 3 is placed. So this is a 4 or a 5. This number is less than 4 or 5, but it's bigger than 2, so it's 3 or 4 only. If it's 3, then that's 3, of course. If it's 4, then we've got more options. This is only 2 or 4. I agree. So this is, again, 3, 4, 5. Maybe not so exciting. This is 3, 4, 5. Let's see. X, X, O. Yeah, there we go. That's it. So the X's and O's are different for 5s. And so this digit sees both of them. So it's not a 4 or a 5. It therefore is a 2. Which makes that an X. This may or may not actually solve the puzzle. That's a 2 at least. So we've done the 2s. This is an O. I mean, that's got to be an O, right? I know where X goes in box 1. That's the point. Because the X's here, if you look at it, go in one of these two. So where does the X go in box 1? It has to go there. Which makes this a 3 and reduces us down to 4 5s only. And we can mark everything else 4 5, and then we can color them. So we've got that's O, that's X, that's O, that's O, and there we go. A lovely, lovely little puzzle there. That one was a little bit more of a bite than I was thinking it was going to, but very nice. And good demonstration of how sometimes coloring can come to your rescue. Even if we did do a Fomino earlier in complete monochrome somehow, which feels like the ultimate in sacrilege, but what can you do? Alrighty, we're going to have to wrap up there for today, though. So thank you, everyone, for hanging out. Yeah, the slight issue with resolving the puzzle at the end, but that's okay. We can forgive these small 2 solutions is a fine number of solutions for a puzzle to have. But Anyway, do please give the stream a like if you have not yet done so. I've had a few streams where only like one person has liked, who I greatly appreciate, Laura, or whoever the one person was. It was probably Laura. But others should also do this. So you have to click thread over in puzzle thingy. Uh, in the Zetamath Discord, but if you click threads, it will show you the threads, which includes an invitation to puzzle submissions and Zeta 6x6s. Yes, I'm definitely going to have a look at the Sudoku Maker template and bookmark it so that I can steal those, or I will forget. But I think probably the answer is I will do it and then figure it out. But yes, especially as our air conditioner attempts to break in some mysterious, confusing way. I appreciate donations to keep us cool in the heat and everything. So if you would like to donate, if you've always wanted to donate but haven't quite taken the time, we'd greatly appreciate if you did. You can click the join button down below, or if you'd rather do it on Ko-fi or whatever else, we appreciate that as well. We do try to give back to members, so there may be a picture of this puzzle resolved going in the Zetamath exclusive Discord, where you can chat with only other people who support the channel, and I may or may not have randomly filled in some 4s and 5s in the grid in said puzzle. You'll have to join the exclusive room to see, but that's going to be it for today's stream. Thank you so much, everyone. I'll see you all real soon. Bye for now.